Hello friends, my name is Fabio and welcome to this complete course for beginners in AutoCAD. This video is intended for learners that are using the software for the first time, but as you can see, it has 4 hours of length. Here we will have time to explore all the basics and get deeper in some topics that I find useful to learn. In fact, this video is a compilation of 3 tutorials that I decided to put them all together in just one, as I know that some users prefer to learn with the full content in only one video. But of course, in the case you prefer to watch them separately, please find the links in the description of this video. Then you will notice that in this video I'm using the versions AutoCAD 2020 and the version 2022 in the last tutorial of the course. But don't worry, in the case you have a different version, even if it is a bit older, that's not going to be an issue, because I will conduct the lesson in a way that works for all. Now it's time to start. Okay, this is the AutoCAD default display, which consists in different areas. Above, at the left, you find the application icon. This is the menu where I can open a new document, open a file, or do operations regarding saving or exporting a file. Then, the main part at the top is called the ribbon. There, you find the majority of tools you will need during the program. Right above, you can find these tabs which group the buttons in different categories. For example, the current one is the Home tab, which has the most used icons. If you switch to the Insert tab, I find in this case icons related to this category. Then, inside the specific tab, the icons are subgrouped in panels. For example, in the Home tab, the first panel have the icons which can perform drawing actions. In the second panel, they are related to modifying objects. And on the third panel are the annotation icons. Additionally, when you click in a panel that has an arrow facing down, it shows extra icons, which are used less often. When a panel has a diagonal arrow at the right, I can access to the settings window of this category. Now, let's show you how to use tools in AutoCAD. For example, imagine I want to draw a line. As you may guess, I can click in the icon here, I go to the workspace, I click for the first point, and then, where I want the second point, I click again. Simple. Then, I'm going to repeat the process, but this time I want you to pay attention to this, the command bar. This shows the operations that are taking place during the project. I will show you. I click again in the line icon, and you can notice here, line specify first point. The first word which appears in capitals is the command name, in this case line. Then, that's the prompt sentence, which tells me what I should do next. Though, I click here to specify the first point, then it asks to specify next point, click again. As you see, I just draw a line, but it keeps asking for specifying another point. It would draw a new line. As I don't want, I can press Escape to exit the line command. In conclusion, to perform any action in AutoCAD, I can type its command name. For example, I type line and press Enter, and I can draw a line. Then press the button Escape to leave the command. Now, I want to draw a circle. I can click in its icon, or type the command name. which is circle. Additionally, each command has a shortcut called alias, so I don't need to type its full name. For example, L is the shortcut for the command line, and C is a shortcut for circle. During this tutorial, each time I introduce a new command, I make an annotation at the left part of the screen showing the command name, the alias and its location on the ribbon. This way of inserting commands makes AutoCAD easy to switch from different versions. If for any reason I'm going to a computer that has AutoCAD 2007, which had a different display than this one, I can still work with no problems, because the command names and their shortcuts are the same. Of course, some functions were not available in that time, but almost all the basics didn't change. The same applies to the version in Mac. Even AutoCAD 2020 there has a different display, the icons are in different places. You can just type the command names and don't need to worry to find them out on the screen. How to use the mouse in the workspace. Having a mouse is very important for working in AutoCAD, as it's much more comfortable than using just a touchpad, especially for zooming or moving the workspace area. Let's see the functions of the mouse buttons. Here I attach this image to help you. Mouse wheel. With the mouse wheel, I can zoom the workspace. It's very simple. If I scroll up, I zoom in. If I scroll down, I zoom out. The zooming always applies to the exact location of the pointer. For example, in this situation, if you want to zoom these objects, I need to move the pointer over them, scroll up, and you notice they are filling all the screen. Simple. To move the workspace area, press and hold the wheel. When you see this hand, you can move around. Left button. Clicking with the left button, I can select objects, like this circle. If I want to select the circle and the line, I can click first in one, then in the second, without pressing the Control key, unlike other programs. But now, imagine you have a bunch of objects to select. It could take a long time to select them all. For that reason, if I click in an empty space, a selection area opens. This allows me to select more than one object. However, this is important. There are two kinds of selection. If I open the area to the right, the color is blue. If I open to the left, the area appears in green color. What's the difference? When I open to the right, blue color, I have to cover the entire object to select it. If I would open to the left, green color, it's enough if I only cover one part. Also, you can understand if the object is going to be selected when you see it turning bold. Now the right button. The right button opens this panel with several options you can choose. But when you select an object and right-click, you can access, for example, to its properties. I click. It's a long list over here. I'm going to close it. However, there is a compact version of properties, Quick Properties, which contains the most important features. For this line, you can see the object type, line, color, layer, line type, and length. By the way, in the quick properties of this circle, some of the topics didn't pop up for the line, as they are more relevant for circles, like the diameter, radius, or area. In this chapter, I'm going to teach you to draw lines properly. The line is probably the most basic tool and the one you will use most of the time. Before, I showed how to draw a line, but without any specified length or direction. I mean, if it's horizontal, vertical, or if it makes an angle with the x-axis, for example. That's exactly what you will learn the next few minutes. Draw a horizontal line. To draw a horizontal line, I need to activate first the command line. I can click on the icon there or type the command name, as you remember from the first chapter. Or I can simply type L, it's the alias for line, and press enter. I click anywhere on the workspace for the start point. Then I drag the cursor to the right and you can notice this dashed green line with these labels saying polar and 0 degrees. If I click right now, the line becomes completely horizontal. This happens because I have the polar tracking turned on. This icon located in the status bar. The polar tracking allows the cursor snapping to certain angles. By default, these angles are set for 0 degrees, 90 degrees, 180 degrees, and 270 degrees, making the lines vertical and horizontal. Now look what would happen if the polar tracking is off. Click on the icon, it's disabled now. Then I'm going to draw a line again, type L, press enter, click for placing the start point. Then, as I'm trying to draw a horizontal line, I realize that the dashed green line is not there. That means when I click, even the line looks horizontal, there will always be a slight deviation. So I strongly suggest you to use the polar tracking whenever you are making precise drawings. Draw a line with specific length. This time I'm going to draw again the horizontal line, but with a precise length of 100. It doesn't matter the units for now. As the last command used was line, I can press enter to revert to the previous one. Look, it turned on again the command. I click, I move horizontally to the right. Now that the line is on the direction I desire, I can type 100 and press enter. Easy! You just drew a horizontal line with a length of 100. But be aware, when I type the length, I cannot change the direction anymore. See, I move the mouse and nothing happens. So, if it's not on the direction you want, you can press escape. Now I can make it vertical, for example. Insert the length again and press enter. To confirm this, I click on the line, right-click, go to Quick Properties, and here you have it, length 100. Ortho mode. If I want to draw only orthogonal lines, I can click on the icon Ortho mode, restrict cursor orthogonally. Then, when I'm drawing a line, I can only make it horizontal or vertical. This can be useful if I'm at a part of a project where I just need those type of lines, like in the example here. Now, let's draw this line here with 70 of length, but with a 30 degrees angle from the x-axis, which you can check looking at the UCS coordinates. They are by default located at the left corner of the screen, here. So, I draw again a line, start point, I type 70, but this time, instead of pushing enter, I press the button tab, the one above the caps lock. With this way, I locked the length, but I can choose the direction. I place the pointer more or less here, type 30 and press enter. As you see, it's quite simple. Then, look at this different situation. The line makes the same angle, but in the opposite direction. I do the same as before, type the length, then look at this label showing the current angle while I'm moving the cursor around. It's increasing until I reach half circle, 180 degrees. Then it decreases, as now it's showing the other side angle. Basically, if I'm below the x-axis and type 30, the angle starts again in the same place but in a clockwise direction. Next to the line icon is the polyline. A polyline is a connect sequence of lines created as a single object. For example, let's draw this exercise here. I click in polyline, choose a start point to draw the first line, go up and make sure you have the polar mode switched on. Type 20, press enter. Then to the right, I type 25, press enter again, and finally, vertically down. This is important, always click when the polar tracking is on the screen. Type 20 again, press enter and escape. So, if I click in the polyline, it selects the full sequence, as you see. Although I could use the command line to draw the same example, all the lines would be considered as separate objects. Now that you know the basics to draw lines, I want to introduce to you a very important function in AutoCAD, the Object Snap. This will allow us to make our drawings with the maximum precision. Take a look at the next example. Let's draw it. I can use either line or polyline command. I choose polyline. I'm going to type its shortcut PL. Draw the first line. Then the vertical one. As there is no line to continue here, I press escape. Now, the third line has to be connected to this intersection. I turn on the command line, I move the cursor near the left end of this line, and look at this green square appearing here saying endpoint. The same happens when I go to the other side. You can see it again. If I click right now, the next line starts automatically from that point. And it means the three lines are now connected to each other. Type 25 and press enter. Those green squares only appear because the object snap is active. It's this icon at the status bar. At the arrow just next, I can see the modes that are currently active. See here the endpoint, which is an extremity of a line segment. Now I'm going to introduce you also the midpoint. First, I'm going to click in it because it's not active. Then I want to draw a line from the middle point of this one. I activate the command line. As you can see, this triangle indicates the midpoint. I click now and the next line starts exactly from there. Object Snap Tracking. This is a very useful function, and I will explain it with an example because I think it's easier to understand. We have this example here, and we want to draw this line which is located at a distance of 30 from the right. I turn on the command line. Place the cursor on this endpoint. Drag left slowly so that I see this label that says extension. In this moment, if I type 30, the new line starts with that distance from the endpoint. It's simple, and with this we can avoid drawing extra lines. Then you just need to draw the remaining objects. To connect this line with the rectangle below, drag it down until I see this cross here. Now click and press Escape. Another way to use object snap tracking can be when I am drawing this rectangle. I can draw an extension line up from this point until I intersect the polar tracking of the line I'm making. Like this. So these kind of things are very interesting to play around. Now you need to make a bit of practice to strengthen the knowledge you got in this video. For that reason, I prepared these exercises for you. You can get them in PDF by clicking on the link available in the description. Part 2. I am going to explain to you briefly more drawing commands. Rectangle. A rectangle is in reality a polyline. It's just a faster way to draw this kind of objects, as I just need to specify 2 points. I'm going to show you. The command is this one. Specify the first point, and then I only need the opposite corner. I can simply click to place it, or insert the coordinates regarding the first point. That's what I'm going to do. The first blank is for the x-axis. Type 40. Then I press Tab to switch to the second coordinate. This one is for the y-axis. Type 20 and press Enter again. In fact, what I have done was inserting the length and the width. Simple. However, as I still have to take into consideration the UCS coordinates, sometimes the values might be negative. Let's suppose I draw another rectangle but with the start point. The x coordinates would be -40. Click for the start point, then type -40, press Tab, and as the y coordinates are positive, I type 20. Here you have the result. Circle. To insert a circle in AutoCAD, I can click in this icon, as I believe you guessed. Then, just follow the prompts to draw the example here. Specify center point of the circle. OK, I click anywhere. Then, specify radius of circle. It is 20. I type that value and press Enter. Let's do the next. Now check out this tip. As I want to use again the command circle, press Enter. The system automatically reactivates the previous action. This is very important to know, it saves time. I am going to draw the same circle again. Now, look to the prompt at the command bar. Specify radius of circle or diameter. So, instead of typing a radius, I can switch to typing a diameter. I do it by clicking on it or simply type the first letter D. Then press Enter. As I'm drawing the same circle, the value is 2 times the radius. 40. Press Enter again. OK, this is just one of the several ways to insert a circle. If I click on the arrow below the icon, you can see all these options available. That depends the situation that you are drawing. Arc. An arc is a section of a circle and, like the previous command, there is an arrow below the icon with different ways of specifying points. I'm going to draw the arc of this example above, and the best option here is inserting the start point, then the center, and finally the end point. By default, AutoCAD draws the arc in the clockwise direction. Let's click on the arrow, then find Start, Center, End. Click on the end point of this line for the start point. The center is the intersection between both lines. And finally, the end point is this one. See how the arc is being drawn clockwise. Modifying objects. Until this moment, I taught you the most used commands to draw in AutoCAD. In this section, I will introduce to you commands that will help you in modifying objects and to be more effective while drawing. I'm going to start with the basic ones. Move. To move an object to a different place, for example, want to move the small rectangle to a distance of 60 to the right, click on the icon, select the rectangle, press Enter. Specify a point from where I want to move the object. Then I move to the right, horizontally, and type the distance of 60. Press Enter. In the following example, I want to move the rectangle to the other box, which is located at the same distance from the corner as here. I activate Move again, I select the object, press Enter. But this time the base point is going to be the corner. Then I click in the next corner to move it there. Copy. This command works in the same way as the command Move. I'm going to copy the object to the first rectangle. I use this base point. Then I can copy it in this intersection. Then I realize I can keep copying the object the number of times I want. Do you see? It's very nice this. And when I'm done, I press Escape. Rotate. To rotate objects, I can use this command. Let's see how it works. I click on the icon, select the objects, press Enter. Then I choose a base point where the objects can rotate around it. As the polar tracking is on, I'm going to rotate them 90 degrees to this side. Another situation. The same objects are in this position. If I try to rotate them back to the position they were before, the polar tracking doesn't work this time. However, I can use a different way. If you look to the prompt, there is an option that says Reference. To use it, I can either click on it with the mouse or type R. Usually the first letter is enough. After, I can specify a reference angle or draw a reference line. Let's draw a reference line, I prefer this. Click here for the first point, then for the second point, I choose this endpoint. Finally, I can rotate until the polar tracking appears. Now, look at this polyline. With the command Offset, I can inscribe that polyline inside, with a specific distance. That distance is called Offset Distance, and it has a length of 10 in this example. Let's do it. The icon Offset is this one. Click on it, then, for Specify Offset Distance, I type 10. Select the polyline, I move the pointer inside and click there to draw the new polyline. By the way, if I click outside the area, the new polyline offsets outside the original one. The command offset can also be applied to lines. If I have this line and apply offset to it, a new line shows up parallel to the first one. Now, I want to show you a situation that happens to a lot of people. I'm going to draw a rectangle with the command line. Then, I want to offset the lines like before. I type O to activate the command, specify the distance of 10, and when I click to offset, I realize I can only click on one line at a time, and the result is different than when I apply to polylines. However, I can easily merge lines in a polyline. There is a command for it, join. I type join, or I can still find the icon on the modify panel, here. It's very simple. Select the lines to merge and press enter. As you see, now I have a polyline. Finally, if I do offset again, the result will be identical as my first example. Command trim. In AutoCAD, we often need to cut parts of objects we have drawn before. For that, we can use the command trim. Let's check out how it works. I'm going to start with a very simple example. We have these lines, and I want to erase this segment. I click on the command trim, it's located there. Select both lines, press enter. Then, if I drag the pointer over here, the screen shows that this part will be erased. The same happens when I move the pointer to the other segments. I click on this one and you see it disappearing. It's done. To leave the command, press enter or escape. Look to the next example. This time we have 3 lines. I turn on trim again, select all the objects, and then I can erase any segment between any intersection, as you see. Now, suppose I want to erase all this part of the horizontal line. Turn on trim. The vertical line on the right I don't need to select, just the other 2. Press enter, and when I'm going to click on this line, it erases everything from the intersection of the lines I have selected to the right. Maybe for this situation this didn't make a big difference, but look at this case. Here I want to delete all this part of the line. If I select everything, then I need to erase one by one. It takes a long time, so it's better to only select the lines I'm going to use, like this. Of course, I can use trim not only for lines. It works for other kinds of objects. For example, I want to change this drawing to that one. I activate trim, select everything, press enter, and finally click on the parts to erase. Extend. This command is used to extend lines. In the example here, I want to extend this line to intersect the vertical line on the left. I am going to click on the arrow located next to the command trim. Then I select Extend. First, I have to select not the line that I want to extend, but the one where the extended lines will connect. So it's this one. Press Enter. Then I select the line to extend. To extend the line to the left, I have to click on the left half in order to work. Look, if I drag the pointer over the right half, nothing happens. I go slowly to the left, and after passing the middle, the extension appears again. I click and press Enter. In this example, I want to extend all the vertical lines on both sides. I type EX, press Enter. Select both horizontal lines. Press Enter again. To extend the lines up, I can open a selection area to cover the upper part of all vertical lines. I click, then I do the same for the part below, to extend the lines down. When I finish, I press Enter to exit the command. Of course, in this situation there is a faster proceedment, by opening an area that covers both line sides. That extends both parts in just one step. Mirror. With this command, we can copy objects symmetrically. This is how it looks. Also, when we need to make a symmetrical drawing, we can just draw half of it and then use Mirror in order to complete the process without spending time in drawing. Let's see how the command Mirror works for these objects. Click on the icon, select everything and press Enter. Then the prompt asks me to draw a mirror line. I'm going to insert the first point at a distance of 20 from the objects. I hover the mouse over this endpoint, move right, type 20 and press Enter. I'm going to draw the line vertically and you can see everything reflected as a mirror. I click for the second point. Now, the prompt sentence says, erase source objects. I choose no to keep the original ones. Notice that all lengths are kept, including the distance between the objects and the mirror line. Now check out these considerations about command mirror. It doesn't matter the length of the mirror line, just the direction. As you can see, if I draw a long vertical line, the result is the same, only if I rotate it, the objects are placed differently. To make a symmetrical drawing, I just need to draw half of it, because if I draw a vertical mirror line in this endpoint, the new mirrored objects connect to the original ones. It's simple. Sometimes I don't want the original objects. In the option Erase Source Objects, I choose Yes. That's the result. Editing objects using grips. The blue icons that show up when I select an object are called grips, and they allow me to edit it. When I select the line, there are 3 grips. If I click in one at the extremity, I can change the position of that point, keeping the other end in the same place. If I click on the grip in the middle, I can move the line without changing the length and direction. Now let's see some editing tips. Change the line length by moving one of the ends. I'm going to click on this icon. I drag left, I'm going to type 10, and the line length increases to 80. Of course, this also works if I want to make the line shorter. Click again. This time I drag right, type 10, and the line returns to its previous size. To type a new length to the line, I click on the grip, drag left, and this time I press the button Tab, and the input switches to the full length. I am going to insert 120. Then, let's check out how grips work on polylines. The end grips of each line works in identical way. I click on this one to change its position, and you can see all the other vertices don't move. Of course, this may cause me to deform the polyline. Now, unlike the lines, the grip on the middle has a rectangular shape. I'm going to click on one, and I can move that full line. Then the rest of the polyline has to adapt to its new position. For example, I move right, type 10, and you can notice this line increases 10 of its total length. So we reached the end of the second part of this tutorial. Now I prepared more exercises for you in order to practice what you have learned here. The link is in the description of the video. After, don't miss the third part of this course, as I will keep teaching very important features for beginners, as set up units, work with layers, plot drawing, and more. Part 3. Until here, I taught you commands to draw objects and modify them, but I haven't mentioned any units for the dimensions. When I was drawing lines, I said, draw a line with dimension of 50 or 100. I didn't say if it was meters, millimeters, inches or feet, but I'm going to talk about this now. First of all, AutoCAD uses dimensional units. This means that it's up to me to decide what is the unit of a line that has length of 20, 50 or 100. It's very simple. Let's suppose I want to make a project in millimeters. That's the unit I usually work with. I want to insert a line with 5 millimeters of length. I draw the line as usual, and when I want to set up the length, I type 5. Then, I'm going to insert a line that measures 1 meter. I do the same, but this time, for the length I type 1000, because, as you may know, 1 meter is 1000 millimeters. Now, let's go to the Unit Properties window. I type units and press Enter. Here, on the length section at the left, you can choose the format for units of measure. If you work in millimeters or meters, you should use decimal units. Instead, in some countries it's more common to use inches and feet. In this case, engineering or architectural units are more suitable. Below, you can set the precision. In this drawing, I consider the units millimeters, and I don't need decimals, so I choose the first option. At the angle side, I can choose the units for angles. Most of the time I use decimal degrees, but there are others here that could eventually be more suitable for you. The units in insertion scale are used only when I insert objects or drawings from a different file. Usually, when we start learning AutoCAD, I don't need to insert anything external. But, in my opinion, it's better to specify the unit. I click on millimeters. When I finish, I click on OK to exit. Layers. Layers is how AutoCAD organizes objects. For example, have a look to this file. Here I have 2 floor plans. It's a proposal for converting offices in flats. So, instead of having the objects all together, I decided to organize them in different layers. I am going to click on this icon to open the Layer Properties Manager. Here, you can see that I created layers to group different categories of objects. For example, I placed the windows in one layer, the walls in another, and I did the same for the doors, text labels, and so on. There are also other advantages in using layers. I can set up specific colors to distinguish them. Another thing, for easy access, I can drag this window to the left and then I click on this icon to hide it automatically. Then I just need to drag over the tab to see the layers. Now I am going to explain to you how we can work with layers and tell you some considerations. New layer. If I want to create a new layer, I click on a blank space on this window with the right button. Then I click on New Layer. Then I can set up a name for the new layer, for example stairs. And if I click on the color, for example, I can change it to the one that I want. I'm going to choose this yellow. Under line type, I have a continuous line by default. However, if I click on load, I can find several line types, dashed lines or other formats. Clicking on this light, I can turn off a layer. For example, I'm going to turn off the layer doors, and you can see those objects disappearing from the screen. There is also the mode freeze. Even it looks like it has the same effect as turning it off, freezing a layer releases it from memory. You can notice the difference in the performance when you work with very large drawings, especially freezing layers that contain loads of 3D objects. Now, suppose that I want to move these objects to the layer stairs. I have to select them, go to the Layer tab, and change to stairs. You can see that they changed the color. Then, I want to draw a new line in a specific layer. First, choose the layer and then I can draw the line. It's simple. Always specify the layer before drawing to avoid changing it after. Isolate layers. To isolate a layer, I can click on this icon. Then I click on one object of the layer that I want to isolate. This operation locks all the objects inside the other layers, meaning that I cannot edit them. Now, this is useful for me to modify objects from this layer text. For example, I want to move all the text to the left. I activate the command move, open a selection window to select the objects, click for a base point, move left and click again. To restore all layers that were locked before, I click on the icon right below and isolate. Layer 0. If I move the pointer over the layer properties, you can check here the layer 0. This is the default layer anytime I start a new file. In any project, I recommend to you to keep this layer without objects there. You cannot rename it or delete it. However, this layer can be useful for creating blocks, which is what I'm going to explain on the next section of this video. Sometimes we draw something that it's easier if it would be a single unit. For example, a door. If we want to copy it, I have to select all the objects that compound the door. If we convert all these objects to a block, they act like a single object. So, I want to convert this door to a block. As it's on the floor plan, to be easier to select it, I'm going to isolate the layer where the objects are located in. Click on the icon Isolate and click on any object of the door. Press Enter and the layer doors became isolated. Let's use the command Copy. Now, it's very easy to select only the door with the selection area. That's because all the other layers are locked. Press Enter and I can copy the door outside the plan. Creating a block. Before creating a block, I'm going to move these objects to the layer 0. By doing that, I can later move the block to the layer I desire and it gets its properties. I select the objects and I'm going to click on the icon Create a Block. The block definition window appears. Here, I can set up a base point for the door. I choose this corner here. Back to the window. I have to write a name for the block. I name it as Door. When I finish, I click on OK. So, the block is created. If I click on any part of the door, you can see that this is now a single object. Now I'm going to change the block to the layer that I want. And you can see, while I'm scrolling here, it changes the color to match the new layer. However, if I created the block with objects in another layer, for example stairs, I'm going to create the block. Then I'm going to change the layer of the block to another one, but it keeps the properties of the layer stairs. The layer 0, on the other hand, means that the objects don't have any layer assigned. Check out this example. Add doors to the floor plan. As you know, I have my new block here. With the command copy, I can insert them easily in the floor plan. I just have to click on the endpoints of these lines. A great advantage of using blocks is the ease of modifying them. I go to this button that says Edit Block. Then I choose the block Door. I click on OK. This is the block editor workspace, and also a new tab for editing blocks appeared on the ribbon. Here I can make all the changes that I want to this block. For example, I'm going to draw a circle here. Then I close the block editor and save the changes. As you can see, all the block references of the block door have a circle inside, which can save amounts of time. In this section, I am going to explain how you can print in AutoCAD. I know that a lot of people struggle with this topic, as it's a bit complex, but I will explain the most important tips to make it as simple as possible. First of all, look at the tabs located here. The first one that says Model is where we can make all the project. This workspace seems to have an infinite area, so we can make the drawings that we want. But of course, the larger the file, the slower the computer gets. The tabs that say Layout are used for printing. I'm going to Layout 1. Here, there is a paper with a specific size. And these drawings is what it would be printed. To print properly, we should specify the paper size that we need. I am going to click here with the right button, and then click on Page Setup Manager. In this window I choose Layout 1 and click on Modify. So here you have the page setup. First, we should choose the printer by clicking on this tab. If we want to save a page in PDF, there are several options here regarding the file size and print quality. I usually use this one, DWG to PDF. To change the paper size, I have to click on this tab. For this case, I want A4, this one. On drawing orientation, I choose between landscape and portrait. Finally, click OK and close to save changes. Now that we have the paper size, we have to decide what we want to print on there. On the Layout tabs, there are two spaces, Paper and Model space. We can switch between them here. Currently, we are in the paper space. If I apply zoom or move, It works for the paper. Notice this rectangle here where I have the drawings. It's a viewport and it's like an access to the project. I am going to double click inside and it switches to the model space. Now if I zoom, the paper doesn't move, just the objects that I drew. As well, if I draw a line here, it will appear exactly in the same place in the Model tab. Change the size of the viewport. I'm going to click on Model to switch to the paper space again. At this moment, I can select the viewport. Then, with the grips, I can modify it to cover the entire paper. Double-click to go to the model space. Now, I can zoom in the drawing or put a specific scale for the paper. It's here. I specify, for example, 1/100. When I finish, I am able to print the drawing. Click here with the right button and this time I click on Plot. Continue to plot a single sheet. Here I can click on OK to print, or in this case to export the file as a PDF. Some printing tips. Hide the viewport. When I plot the file, the viewport appears by default on the paper. If you want to hide it, follow the next steps. Go to the Layer Properties Manager and create a new layer just for the viewport. Switch to the paper mode. Click on the viewport and move it to its own layer. Then, go again to the Layer Properties and freeze the layer. You can see that it's not appearing anymore. So, if you save as a PDF or print a file right now, the viewport is not visible. Have different colors on the viewport. The default AutoCAD workspace uses a dark background, with a reason to be better for the eyes when working for several hours. Because of that, it's common to use light colors in our project. The problem is when we switch to the layout mode, the colors can be too light for a white paper. For example, the doors are a bit hard to see. Don't worry, it's possible to set up different colors for printing. First, you have to double-click on the viewport to switch to the model space. Go to the Layer Properties and you can see this column with the label VP Color. If in your version is not located next to the Color tab, look at the right end of this table. Then I'm going to change the color for the layer doors. Click here and put this one, for example. Now it's much better. Insert text. I am going to explain to you quickly to insert text in AutoCAD. It's not hard and there are two types of text, single line and multi-line text. I will start with single line text. First, we insert the start point. Then, this line specifies our text height. I can either click or specify a distance. I'm going to type 100. Press Enter and then I choose the direction. If I want to type horizontal text, I need a horizontal line. Now I can write anything, and when I finish, I click in a different place to write another text. Or if I don't want more, I can just press Enter or Escape. Now let's see the multi-line text. Activate the command. Choose first point, and I specify a selection area to fit the text in, but just the horizontal length. The height of the rectangle doesn't matter. Then I can write the text. Unlike the single text, this time a temporary tab for editing text appears on the ribbon. Here I have options for editing a paragraph and much more. If I want to change the height, I need to select the text and change it here. As you notice, it's very simple to write text in AutoCAD. Part 4. In this part, I'm going to teach how to scale objects, how to attach an image to the drawing and apply a scale in order to have the real dimensions, how to import a PDF file, and this is especially useful when the file was previously created within AutoCAD, how to stretch objects, and how to fill enclosed areas with the command hatch. Of course, as always, I like to share some tips with you along with the explanations. Let's start. Scale objects. Let's learn how we can scale objects. This command is not hard, but you should understand it well if you want to use it properly. To turn on the command scale, click on the icon. It's this one. Select the objects I want to scale. In this case, I want to scale the figure on the right. Choose this base point. Now, there are several modes to scale objects. The one by default is to insert a scale factor. I am going to type 2, and the lengths of all these lines changed to double size. Okay, I'm going to repeat the process, but this time I want to shrink the objects to half size. I type SC to activate the command again. Select the objects, but now I don't select the dimension line. For the scale factor, I insert 0.5, and the lines were converted to half of the length that they used to have previously. Look that this dimension line was updated, even it was unselected. Scale with a reference. Now I'm going to show to you how to insert a scale with a reference. I turn on again the command scale and select the objects. Select the base point. Looking to the command bar, it says specify scale factor or these options, copy and reference. I'm going to use the shortcut R to use the reference. And what I need to do here is draw a reference line and type a new length for it. So it's very simple. I click for the first point and then I click for the second point. Finally, I type the new length, which is 55, and press enter to confirm it. Use scale to import a PDF or attach an image. In AutoCAD, it's possible to insert an image to use as a background of a project. For example, images from Google Earth can be used to draw site plans. To attach an image file, I go to the Insert tab at the ribbon, click on Attach, and select an image from my computer. I choose this one. In this window, I can set few options. Here, it's important that I tick on Specify on screen the insertion point. Otherwise, the image is inserted on the coordinates which are specified here. Okay, except if it's exactly what you want. I click on OK, and now I click for placing the image. And for the scale factor, I leave it for now, press enter. So what happens here? Most of the time that we insert an image, it's not scaled properly. For example, I have a reference between these 2 points, which is approximately 206.17 meters. If I use the distance command, I type di, press enter, I can notice that the distance here is a bit longer than what it should. No problem. I can use scale with reference. I turn on the command scale, select the image by clicking on the border. If I click inside the image, it doesn't work. Change the mode to reference, and then I draw the line between those 2 points. I will try to make it as accurate as possible. Now it should be correct. And I want to share a tip with you. Always try to use a long reference line. Because if instead my reference was a short distance, after scaling the image tends to be less accurate. To import a PDF file, I can click on the icon also located on the Insert tab here. I'm going to choose the file of the exercises. Then the window that opens has a bit more complex options than for attaching images. Actually, this is a very useful function because if I insert a PDF that was previously created in AutoCAD, I can recover all the layers and the objects. As this PDF has 2 pages, first I need to click on the one that I want to import. On PDF data to import, I tick on vector geometry to import the lines, polylines, circles, arcs, and so on. If I tick on True Type Text, text created with a font that has this symbol will be automatically recognized as text. In AutoCAD, most fonts available are True Type, so usually this is not a problem here. The option below, I tick on it if I have raster images attached. In this case, there aren't, so I keep it unselected. Then, on the right panel, I tick on the first option, Use PDF Layers. On the panel below, you can find more options to add. But for now, let's click on OK. And I am going to insert a file on the project. Nice. Now, if I go to the layer properties, I can see that new layers were created from the PDF, and due to the fact that I made this drawing in AutoCAD, the layers are the same from the original DWG file. I'm going to check out how the objects look like, and you can see here polylines among other objects. Also, look how the text was recognized. If the text was not on a TrueType font, it would be splitted in very small lines and arcs, which wouldn't be so interesting. However, not everything is perfect. The dimension lines are not recognized, neither block references, which means I have to create them again. But in general, insert PDF can be very useful. Just be aware, it's only available in the versions after AutoCAD 2017. Stretch objects. Sometimes in AutoCAD we need to stretch figures. Let's learn how it works. First, it's important to have in mind that this operation doesn't work for blocks. As you can see, here I have only lines and polylines. Let's do it. I am going to click on the command stretch. It's this icon here. Then I have to select the part to actually stretch. So I open the selection from the right just until here. Then I specify this base point. As you can see, I'm extending and moving objects to this side. And as the dimension line was in the selection, it is also readjusting. Now I can click to place the objects exactly how it's on the screen, however it's without any kind of precision, or type a distance to extend. If I type 800, actually I add that value to the original length of 600, and the total is 1400. The way that the objects stretch depends only on the selection. Even I select a different base point, the result is the same. Let's repeat this again, and this time I want to change the selection to cover also this line. I press Enter, and you can see the object stretching differently. Now I want to try to stretch vertically. I select the objects, press Enter, and oh, it's not as I was expecting. But I select all the objects. Why does this happen? When I was doing the selection, I kept these sides outside of the selection area. And even everything was selected, because the external rectangle is a polyline, a single object. The really important thing here is what actually I am covering with the area. Hatch. Filling enclosed areas. In this section, I will be talking about a drawing tool which is used to fill enclosed areas. It's the command hatch. But first, I am going to create a new layer in this file. Let's check out if you remember how to do it. I go to the Properties Manager, click with the right button, and New Layer. I name it as simply Hatch. Then I'm going to choose a color for it. For example, this kind of pink. OK, now I'm going to turn on the command hatch. It's located here at the drawing panel. Wait a few seconds if you want to read the description of this tool. Sometimes it can be interesting. Then, to apply a hatch, click on it, and I have to click inside an enclosed area. It can be any of these rectangles. I click to fill this one. Ah, it's in a white color. I forgot to change the layer. Yes, when you create a new layer, you still need to set it as the current layer before you draw the objects in. Otherwise, it will not work. Go to the Layer tab and click on Hatch. Now I see this message appeared. The current layer will be turned off. What do you want to do? For any reason, this bulb is switched off, and if I draw objects on that layer, they will not be visible. Click to turn it on. I'm going to repeat the process. Click on the command hatch and fill that area. Now it's on the correct layer. Press Enter to confirm. Then, by dragging the mouse over, you can see that it's a hatch object. Now I will show you another way to use hatch. I click again here, and then, instead of pressing Enter, I fill a different area right away. What happened is that both areas are now a single object. Hatch Editor. Above, a new tab appeared at the ribbon specialized for editing hatches. I'm going to show you briefly the functions here. I'm going to click on this button at this panel, and you can see a lot of patterns to use here. The first one, Solid, is the simplest one. It fills the area with just one color. I choose, for example, this. Now let's have a look at the options at this side. On these controls, I changed the scale. Look how is the effect. On the Angle tab above, I can rotate the pattern. Finally, on Hatch Transparency, I add a transparent effect to the objects. I want to mention one thing. When I first tried to change the scale by clicking on the controls, I realized that these values didn't change a lot. Even if I type a number with decimals, it shows just 0. When this happens, it means that I should go to the unit properties, type UN and press enter. And in this tab, I need to set decimals. For example, 2 decimal cases. Then it should work fine. Part 5. How to use array. With the command array, we can copy objects arranged in a pattern. There are 3 different modes: rectangular array, polar array, and path array. I start with rectangular array, and for that, I just need to click on the button. That's the mode set by default. Then I'm going to select these objects and press enter. So an array was generated and a special tab on the ribbon has appeared. Now I can edit this pattern as I wish. Here I can set the number of columns and rows. If I decrease the number of columns, for example from 4 to 3, as you can see on the screen, the last column is suppressed. The array creation, I find it very intuitive. And I think it's easy to understand the options here, while looking to these little drawings there. The distance between is the distance from the origin to the beginning of the next element. The distance total is from the origin to where the last element starts. Simple. I'm going to change the distance between rows to 200. And look how the pattern moves. Of course, the total distance was updated in order to match to the new distance between lines. To exit the array mode, I press escape. Now, if I want to confirm the distances, I can use the measure tool or type DI and press enter. Notice that the vertical length between 2 elements matches, as well as the horizontal length. Grips in an array object. Whenever I select an array, you can see these dynamic grips, the blue buttons here, which I can use them to modify this array. For example, if I click on this one, on the second row, I can change the vertical distance between 2 objects. For that, I simply type the new length. To change the horizontal length, on the other hand, click on this one. If I click on the grip at the last row, I can add more, for example, 7. If I click on this side, it's the numbering of columns that I can change. The grip on the opposite corner changes both rows or columns by dragging the mouse. Basically, these operations can also be performed on the Array tab, but sometimes it's just more practical with these buttons. Another useful thing in Array is changing the base point. I click on this icon, set the new point, for example, or on the corner, and the grips moved with the base point, but they perform exactly the same actions. Let's make a polar array. I'm going to draw a small circle with its center located at the boundary of this big one, on this side. Now I can click on the command polar array. It's this one there. Basically, what I want is to have this object displayed around. I click on it, then the center point of array is going to be the center of the biggest circle. And that's the result. The program sets 6 circles around by default, but like for the rectangular array, I can edit this on the tab at the ribbon. So, the Array tab for Polar Array is a bit different, especially the panel items. On the first parameter, I set the number of items. In this case, I specify 18, and they cover all the circumference, because I have 360 degrees for the fill parameter. In between, I specify the angle between two items, and in this case, it's 20 degrees. If I try to change the angle to 30, you can notice that it doesn't work, because it's not possible to fit 18 items with that spacement. Let's try 15 degrees. So what happened here? In order to keep 18 items, the angle on fill was updated. Now it's only 255. Grips on Polar Array and tips. The small square on the original item allows me to change the radius of the array. I'm going to set, for example, 50, and this is how it looks like. The grip on the center can be used to change the position of the array. On the other hand, if I click on this little arrow, I change the angle between two items. Let's suppose I want 6 items. The angle to have them distributed equally is 60 degrees. However, it's possible to increase a bit that angle, but the last and first item will stay closer than the others. Path Array. The third array mode available in AutoCAD is Path Array. We can copy objects along a line or a curve. Let's see how it is. First, I'm going to draw a spline, which is a smooth curve. I click on the command located here, Spline Fit, and I can draw a curve by specifying some points. On Spline Fit, the curve crosses exactly the points that I insert. When I finish, I press Enter. Here, by pressing Escape instead, it cancels the command. It will not work. Next, I draw a rectangle on the first endpoint of the spline. Now let's use the Path Array. I click on the icon. Select the object to copy. Press Enter, and then I select my path. So I have made it. However, probably I want to edit the spacement, position, or rotation. At the command bar, you can easily check out that there are several options to edit. Let's analyze some of them. Base point. The base point will be exactly at the start of the path. I click on the option, then I change, for example, the base point to the opposite corner. And that is the result. The object's moved, but without rotating. Tangent direction. This one is useful if I want, for example, to have one of the rectangle edges tangent with the curve. I'm going to click on the button Tangent Direction, then just specify 2 points, and the objects will rotate. But now suppose that I want a path to cross the center of the objects. I'm going to use the option Base Point and click on the center of the rectangles. But it's not snapping to the center point. If this happens to you, it means that you should turn on the mode Geometrical Center in Object Snap. It's this one. Now it's going to appear. I just need to hover the boundary first and click on the center. Array tab on the ribbon. The tab on the ribbon is now specific for path arrays, especially the first panel. I can change here easily the spacing between, total spacing, and number of items. I think the best way to absorb these things is to simply practice. You can play around with all these options, and after a while it will be easier for you. Explode objects. Once I create an array, all the group is considered a single object. Now imagine that I want to get rid of the array. It doesn't work with just select it and press delete. It erases the whole thing, as you see. What I need is the command explode. It basically returns a compound object to its original components. It's very easy to use this. I click on the command explode, select the array and press enter. As you see, all these are now separate polylines. Then I can manipulate the objects as my preference. Consequently, I can explode the polyline in separate lines. Another way to use explode is on blocks, hatches, and other kind of objects. But some of them it doesn't work, like text. Utilities panel. Let's talk about the Utilities panel, and I'm going to start with the Measure tool. There are several ways of measuring, as you can see here. I start showing you the first one, Quick Measure, which is the one set by default when you click on this button for the first time. When I move the mouse over the objects, some dimensions appear on the screen, and these yellow lines measure vertical and horizontal distances between the closer objects. On the other hand, if I try to check the dimensions in a circle, at the first time it looks a bit confusing, all these values here. But they just show the radius of the circle they indicate. For example, 100 is the radius of the bigger circle, as well as 15 is the radius of the small circle. The yellow lines don't measure anything here, just don't care about them. Honestly, this quick measure it's not my favorite, because even it's true that we can have a lot of information at the same time, it can be a bit confusing. But of course, that is just a personal taste. The icon distance, I use it a lot as I find it very intuitive. It simply measures the linear distance between 2 points. Another one which is very easy to use is radius. I only need to click on a circle to check it out. Measure an angle. This one is simple. I can select two lines to measure the angle between them. Or I can check out the angle of an arc by clicking on it. Now let's go to where I was before. I want to focus on something. When I select the objects to measure the angle, this menu appears where I can choose from different types of measures. I'm going to click on, for example, area, and with this I can measure the area of the triangle. It's very simple. I just need to click on all the vertices and press enter at the end. Then you can see in this box the area and the perimeter. But how could I measure the area of a circle since it doesn't have corners? I click on the icon. Then at the command bar I can switch to object. I type O and press enter. Finally, I just select the circle. Quick Select. On the Utilities panel, you can find other tools at the small icons at the right. The first one above is Quick Select. If I click there, I open this window where I can select objects by using filters. For example, I can specify a type of object or select by color. Now, I will select all the objects with color cyan. Click on OK, and here it is. This is the only one in this color. Other options can be select all the objects of a specific layer, or you can select by line type, among other options. If I click on this icon, I select all the objects in the workspace, except the ones that are frozen or unlocked layers. The button below is the quick calculator. Actually, it's a kind of scientific calculator, and there we can do from basic calculations to a bit more complex ones. Part 6. The final part. Dimension lines. Now I am going to teach you how to draw dimension lines. This is a classic feature for annotation in your drawings. In this figure, you can see the dimension lines indicating its distances. Now, to draw dimension lines, there is a panel on the Home tab here. Or if we go to the Annotation tab, we can have all the tools. So there are several types of dimension lines, whose you can find them by clicking on this arrow. For now, let's start with the most common one, linear dimension. To insert a dimension line, I just click on 2 points. Then I click again to put the dimension line on the place that I want. So it's very simple. However, this feature is quite complex, and we usually have to set up some settings. Sometimes the dimension lines are not proportional with the sizes of the objects that they measure. So I'm going to open the Dimension Style Manager by clicking on this little arrow. Here, I need to choose the dimension style that I want to edit. I select Standard, which is the current one, and I click on Modify. Now there are loads of options here. But for a beginner, the most important is the size of the text and arrows, as well as the units. Go to Symbols and Arrows tab. Look for arrow size and put a value that seems convenient. Then the size of the text can be changed in the Text tab. As you see, both sizes have a height of 2. To confirm this, I can always measure the distance here. You can see it's 2. On Primary Units tab, I can edit the unit format. The number of decimals, let's change it to 2. And I can add a prefix or a suffix. For example, suppose that the units here are in meters. I can type the symbol M on suffix to appear after the values. Like this. Other types of dimension lines. As I showed in the beginning, there are more types of dimension lines to use in AutoCAD, depending on what we want to measure. For example, let's measure using the linear dimension, the distance between this point and this one. As you see, it's measuring either the horizontal distance or the vertical one if I move the pointer this way. But this is all fine because I can insert an align dimension. With this option, I can measure objects that are not located in the Cartesian axis. So it's much better, as you see. Angular dimension. Now I am going to click on the angular dimension. This one is still simple to use. I can measure an angle by clicking in 2 lines that intersect each other. The angle itself I can place in any of the 4 sides of the intersection plane. Radius. To measure the radius of a circle, first I'm going to draw one here. Then I choose the option to measure the radius and just click on the circle. I click again to place the dimension line. In this tutorial I want to show you also the arc length. I can measure the distance of an arc. And yes, this only works on arcs. If I try to measure the perimeter of a circle, nothing happens, as you see. Apart from those tiles, there is the automated dimension, which is the icon here. It detects automatically what is the most suitable type of dimension in each situation. For example, if I move this line, this square appears, and I can click on it, and I will place the dimension of the length of this line. I can do the same for the other lines, as you see. For measuring an angle, I have to choose the option Angular. And then I can place it like I did previously. In a circle, the automated dimension places the diameter by default. However, I can change to place the radius instead. Now let's see some tips and peculiarities. Dim layer. On this tab at the panel dimensions, I set the layer where I want the dimension lines in. I choose the layer dimensions as I created it specially for placing the dimension lines. However, if I switch to the Home tab, the current layer is lines. And if I draw a dimension line, you can see that it goes automatically to the dimension layer. Snaps on arrows. In some versions of AutoCAD, like the one that I'm using, the system snaps to the endpoints, midpoints, geometrical centers on the arrow shape. And this is a bit annoying, because usually I only want to snap to the end of the dimension line, this point. And honestly, I haven't figured out yet if there is a way to get rid of those snaps. If anyone knows, is welcome to post a comment on this video. It would help a lot of people. However, I'm going to share with you a good way to deal with this. On Symbols and Arrows tab at the Dimension Style Manager, click on the first arrowhead. And as you can see, on this list, there are plenty of them to use. But for now, I choose None. Automatically, the second arrowhead is updated to match the first one. The result is this. It's easier to snap to the endpoint. Additionally, the distances extend beyond dimension lines and offset from origin are these ones that I show on the drawing. Put 0 for both, and it's even better. I can only snap to the intersection of the line below and to the dimension line end. Basically, you can make all your projects with these settings and just edit the style according to your preferences when you finish. The dimensions will be all updated. Choose the style of dimension line before drawing. Whenever we draw a dimension line, we should make sure that the desired dimension style is active. For example, I'm going to switch to Annotative and as you see, the settings there are different. Another thing, what I have been teaching during this tutorial are the standard dimension lines. All the sizes that we set on the Dimension Style Manager are according to the workspace. The annotative dimensions are the styles which are represented with this icon here. The sizes that we set are according to the real size of the dimension lines on the paper that we print. However, the annotative dimensions is a subject that you will find on the second tutorial, which is going to start right away. Now we are ready to start getting deeper into the program. Here you will learn very useful tips to improve the knowledge you have already learned here. Now, this tutorial is divided in 5 parts, and you can check them out in the description of the video. Let's start. Part 1. Let's have a look at the content. Organize your working area. We can save amounts of time if things are prepared in advance. Annotative objects. By using annotative dimensions, text or blocks, you can have those kind of objects with a specific size when you print your files, even if you have different scales on your viewports in the layout. And finally, you will learn to use the zoom command instead of just scrolling the mouse wheel. This is especially useful for large files, as there are functionalities to zoom specific areas, instead of looking for a specific element for ages. Tips for having a good organization and save time. For me, it's a very important thing, as with spending a couple of hours organizing your layouts and creating personalized templates, you will save a lot of time in the future whenever you start a new project. Save space when using 2 screens. If you have 2 screens on your computer, you can use them as your benefit when working on AutoCAD. As you may be familiar, sometimes we have to open the Layer Properties panel, or open the External References palette, as well as the Properties window. All are using space on your screen. But, however, if you have a second screen, you can place there the palettes you often need in AutoCAD. For example, here I place these ones in a way that I can use them easily all the time. And this is important, the palettes are still on the same position if you open another file or if you close the AutoCAD program and come back just tomorrow. The things will look more organized, which is more pleasant to work. Create a personalized template for your projects. Let's suppose you need to create architecture projects often, and you need floor plan drawings, elevations or location plans. In addition, the scale and the paper size you use most of the time is the same. So, if that is your case, one good way to save time is create a personalized template with everything already set up. For example, look to this file where I draw this floor plan. The layers that I use here probably will be the same or similar in other projects. So, first, I can empty the workspace. Make sure that all layers are turned on and unlocked. Then go to Select All and press Delete. Now I can save this as a template, or saving as a normal DWG file would work fine. It's important that you choose a name that you will remember, for example, Project Architecture. OK, I can continue personalizing this file, for example, edit the units and precision, if I often use the same units in my projects. On the Layout tabs, I can save loads of time if I have several tabs for floor plans, elevations, sections, and so on. I can go to the Page Setup Manager to set the paper size, for example A3, and also the printer if it's the same all the time. Then I can delete the objects here by selecting all. Make sure I am on the paper space. Now, I'm going to add a new layer called title block. And I'm going to draw on the paper a title that can be used on all my drawings. As soon as I finish the title block, I can create a viewport in this layout. I go to the Layout tab, then I click here to insert a rectangular viewport and draw it on the paper. After, I double-click inside to switch to the model space and set up a scale for it. Okay, suppose that most of the time I use the scale of 1/50. I click on it, so I don't need to set it all the time when I start a new project. Then I can rename this layout to ground floor. I double-click on it and I type the name that I want. Then, to create similar layouts, I can right-click here, then move or copy. I select ground floor and tick create a copy. Then I click on OK, and a new tab with the same configuration was created. So, in a project architecture, I can have all these tabs for floor plans, elevations, site plans, or location plans. And when I'm happy with the template, I can save it in my computer. On Save As, click on Drawing Template and save it with the name that you like. I can add a description here also and click on OK. Basically, with this, I can save a lot of time when I start a new project. Annotation in AutoCAD. In the next part, we will focus how to insert annotative text and dimensions. It's simple, we just need to play a bit with scales in the workspace. The text height that we insert for our text is actually the real size that will be printed. For example, in Layout 1, I want to write text in this viewport with a text height of 0.005 meters. This is the procedure. First, check out the scale of the viewport. Double-click inside here and I can see it as 1/200. Then, switch to the Model tab. On the Home tab, go to the Annotation panel, click on this arrow and switch the first tab to Annotative, or to a style that has this icon associated. Change the scale to fit the viewport scale. I click on 1/200. Create a single line text here. The command is up there. Click for the base point, and when you are prompted to insert the height, it says here, specify paper height. I am going to type 0.005 because in this drawing I'm using meters as units. Type the text and click in a different place. Then switch again to Layout 1 and here you have the text. If you print it and check it with a rule, it has to measure 5 millimeters. Now, let's go to another Layout tab, this one. This time I want to add a text to the viewport where I have the door. The scale here is 1/16. So, going back to the model space, let's find the door. I'm going to switch the scale to 1/16 and let's draw another text. This time, for the paper height, I type 0.01, 1 centimeter. Finally, I type the text. When I switch again to the Details tab, I can see the text there. Annotative dimensions. This uses a similar logic as annotative text. We want to add this dimension line with the same 5 mm of text height on the paper. Go back to the model space. First, change the current layer to Dimensions. Then click on the arrow at the Annotation panel, and then click on the second tab, which is the one for Dimensions. Choose an annotative style, this one. Now we have to do a different step. We should edit the dimension style first. Click on this button. In this window, choose Annotative Meters and click on Modify. Here I go to the label text and specify 0.005 for the text height. Then in Symbols and Arrows, I can put the same measurement for the arrow line. Finally, I click on OK and close. To add the dimension line, I change the scale again to fit the viewport scale of 1/200. Click on this icon to draw a dimension line, and I'm going to place it here. When I finish, I can go to the Layout tab, and here you have the dimension line. Okay, it's too light in a white paper. That's no problem. I can click inside the viewport, go to the Layer Properties, and then in Dimensions, I can change the viewport color to a darker one. Now it's much better. Annotative blocks. Now let's check out how we can create annotative blocks. They can be useful for some kind of projects where we add symbols that can represent elements. For example, here, suppose we want to add a socket to this project. As it's a small element to be seen in the plan, we usually represent it as a symbol with a fixed size in order to be easily seen in drawings with different scales. In the example here, this socket has 5 mm of diameter in the paper. Back on the model space, I'm going to zoom in the object. And the first thing, I have to confirm it has the size that I desire. Oh, and don't forget to set the scale as 1/1, because we are drawing an annotative element. Otherwise, the block will be automatically scaled after being created, and I don't think that's what we want. So, as I want this distance as 5 mm, you can see that it's not. I have to use the command scale. So I type SC, select all the objects, press Enter. I can choose this one as the base point, and then instead of a scale factor, I have to choose a reference. Then I select 2 points for my reference line, and then I specify the new length as 5 mm. Oh, and just to let you know, in this project the unit is millimeter. Now that our symbol is in the correct scale, I'm going to convert it to a block. I select all the objects and make sure they are on the layer 0. To create a block, I can use the alias B. To open the block definition to create a block, I type the name for the block, for example, socket. Then we need to tick this box that says annotative. I click on OK, and I can choose the base point, and the block is finally done. The next step is to insert the block on the drawing, but in the scale of one of the viewports. It can be 1/50, 1/100, or 1/200. As you can see there, I decide to choose 1/50. So, on the model space, change the scale here to 1/50. Go to Insert Block, choose the socket, and I'm going to place it where it belongs. I hold this endpoint and put it there. If you go again to the layout mode, you can see it on the viewport with scale 1/50. So until here everything is correct. Then how can I add the other scales? If I access the properties of this block, I can see under miscellaneous that this object is annotative, along with the annotative scale. However, I can easily add more scales here by just clicking on the button at the right. This is the annotation object scale, and I click on Add to add more scales. I choose 1/100 and 1/200 in this list. I click in OK, and here you have them. Then it should be done. So let's change the scale here, and you can see that the object is resized. What happened is that this block has now 3 different scales. When you look at the viewports, the socket symbol has exactly the same size in all of them. And then if you print, you will notice that the symbol measures exactly 5 mm of width. Going back to the model space and select the socket, you can see the 3 scales when you have this button on the status bar turned on. Then let's put it just in another color to be easier to distinguish. Zoom. Now I'm going to talk a bit about zooming in AutoCAD. As you know, the most simple way of zooming, and the most common one, is to scroll the mouse wheel to reach the different parts of our project. However, for large projects, this can be a bit annoying to try to find specific areas. For that reason, there is the command zoom. Let's have a look at it. I type Z and press enter. Then, if you look at the command bar, you can see several ways to use zoom. The option by default is drawing a window on the workspace. For example, if I want to show the staircase division here, I draw a window covering that part, and here is the result. So, I find this especially useful when I want to focus something specific, as the zooming is more precise in this area. Another way of using zoom is using the option All. This sets the zoom to cover all the drawing in this file, including the position of the UCS coordinates in the corner here. Then, a similar option is the Zoom Extends. Very useful, by the way. I use it quite a lot. It shows all the objects covering the full screen. Here, the difference regarding Zoom All is that the position of the UCS coordinates can be hidden. If I click on Center, I pick a point to be placed in the center of the screen. Then, I specify the zoom height by drawing a line here. Simple. Now I'm going to show you something useful for larger projects. In this file, you can see all these drawings of a single architecture project. In this case, it's an exposition center. There are floor plans, sections, elevations, site plans, and so on. On these controls at the top left corner, click on this one that says Stop, and here you can switch to a different view of the workspace. However, the ones here are useful when I have 3D drawings. Look that I can't see anything interesting when I switch to the left or right views. This is because everything in this project is two-dimensional and was created in the top plane. On the view cube, you can understand a bit better the location of the views by default, especially when you click in a corner to switch to an isometric view. Okay, but what I want to do now is actually create a custom view to show up a specific part. Let's go to one of the floor plans located here, and to be more precise, I zoom with Window. Okay, now it's better. Then I go again to Top, and this time I click on View Manager. I'm going to create a new view here on New. And first I need to choose a name. It's going to be Esquema de Instalaciones Sanitarias. Yes, it's Spanish, but it means literally sanitary facility scheme. Then I can put it into a category. It's empty, so I can create a new one. Let's name it Floor Plans. The view type, I keep it still, I don't change it. For the boundary, I choose the current display and click OK to close. Here OK again. And then I go back to top, and on custom views, I choose the one I just created, and you can see it zooming automatically. Okay, it's true that this floor plan was not very difficult to find. However, if you are working in a huge project with loads of drawings, sometimes you can stay looking for a specific detail for ages, like those books where you need to find Waldo. So, now we want to zoom up to these objects. But this time let's do it a bit different. Go again to the View Manager, create a new view called Detail 1 and put it into a new category, Details. And in Boundary this time I'm going to define a view window. I click in this button, then I search for the part that I want. I told you, it's hard. Where are they? Ah, here. So, make a window in the place where I want to zoom. I press Enter when I'm ready, and you can see a preview on the View Manager. I click OK to confirm it and close. So, for the next time I want to go to the Detail 1, it's much faster. Charan! Part 2. Layout tabs extra tips. When we set a viewport to show a specific drawing with a specific scale, we realize that in a small distraction we scroll the mouse wheel and it messes up all the scale. And then I have to go to the scale list and click again, in this case in 1/150. However, there is a very useful tool here. I can lock the viewport by clicking on this icon. Now, even I am in the model space, I can zoom or move in the same way as I was in the paper mode. By the way, I can still draw or erase objects inside the viewport. So, I just recommend you to lock all the viewports when you don't want to change them anymore. Write text and draw the title block on the paper. When you need to add text to your papers, just draw it directly in the paper mode. I mean, outside of any viewport. It's easier and more practical. First, it's text that we don't want to model, as it's only used for annotation. Second, the size that we specify is the paper height. In this case, 5 mm, and I don't have to scale it like in a model space. Much easier. The same applies for the title block. Just draw it on the paper. You can start drawing the borders, then the text using the paper height. In this case, after placing the first single line text, I want 4 of these with the same spacing. I can use here the command copy, then the option array. I type 4, and finally you can click again to confirm the position or insert a specific distance between objects. And then just change the names to the right ones. Okay, I can take the opportunity to explain to insert an image to the layout. For example, if you want to add a logo of your company there, it's quite simple. Go to the Insert tab, Then click on Attach and select an image to import to this file. I select the CAD in Black logo, for example, just to show you how it works. We can insert the coordinates of the insertion point or specify it on screen, and that's what I'm going to do. Click on OK, place the start point. I can click around here. Then it looks like that the image is a bit large, but that's fine. Just press Enter for now, as we can scale it after with a reference. Use the command Scale. Select the image. Click for the base point. Choose the option Reference at the command bar, and then choose 2 points of a reference line to resize it. And this time I will not insert any length, because I don't know it. I just move the cursor in this direction and you can see a dynamic preview of the logo. As soon as it looks great, I can click to place it there. So simple, isn't it? Yes, let's continue. Now we are going to learn to add more viewports on the same paper. Usually the purpose of doing this is to show different drawings or a specific detail that we want to show on a smaller scale. Let's go to the Layout tab on the ribbon. Here we will create a new viewport by clicking in this icon. And there are 3 ways: rectangular, polygonal and object. Let's go for rectangular. So I simply draw a rectangle here. Then I double click inside it to switch to the model space. This time we will use a custom view that we created in the previous chapter. I click on top, go to Custom Model View and choose Detail 1. And look how useful this can be, not need to search for that part, so easy. Next, I go to the scale list and I need to choose one. 1/50, and the reason that I decided to use this scale is because 1/50 is the same as 0.02, which is relatively close to the value that I've got here. And you can see that the drawing didn't change that much. Double click to switch to the paper space and readjust the viewport by clicking on the grips there. And don't forget to lock the viewport to not move it again. After, I can copy this text and place it below our new viewport. Select the text. I'm going to use this endpoint as my base point, and then click in this corner for the second point to keep the same spacing towards the viewport. And rename it with the correct text. Put also the scale of 1/50. Then let's draw a circle here. The radius doesn't need to be precise. On the Layout tab, choose now the option to create a viewport from an existing object, this one. Then click on the circle to convert it to a viewport. And of course, this option only works for enclosed areas. Then suppose what I want here is to zoom this specific part. Move the circle to a specific layer if you want, or put the object just in a specific color. And then I can draw a small circle in the same place of the floor plan to indicate that this area belongs there. And if you want at the end, you can connect it with lines. Other drafting techniques. In this chapter, I'm going to talk about drawing tips, and I will start with the grid and snap modes. Grid and snap mode can be useful when we have to make detailed drawings, especially when they have regular shapes. Let's have a look at them. The first icon at the status bar enables the grid, as you can see here. Try it on your computer. However, you will probably notice that it looks darker than here if you have the default colors. For me, they are a bit hard to see, and that's why I prefer to change them. But okay, this I will explain to you at the end of this chapter. For now, let's zoom a bit and activate the drawing command, for example, line. You can see that the cursor doesn't snap to any point, because the snap mode is off. Let's turn it on, and now yes, you can click on an intersection of the grid line. So it's easily understandable that these tools work together, and there is no point to turn on the snap mode if your grid mode is off. Now, I'm going to click on an intersection of two major lines, and by moving the cursor, you can understand what is the length between 2 points of the grid. It's 10, and the distance of two major lines is 50, because it's equal to 5 minor lines. So, as you can see, this is quite simple. Now, have a look to this drawing. We can easily guess the distance between some points, if they are not that far away. For example, this distance is 100 millimeters, and the width of the rectangle is 200. Because there are 4 big squares, 5, 10, 15, 20, you can just count them. So, to draw that rectangle with the grid is actually easy. This is the first corner, then the opposite will be 4 large squares to the left and one above the line at the bottom, so click there. You can zoom a bit to make sure that you click on the correct point. It's better. Okay, now let's learn to edit the snap and grid spacing. Click on Snap Settings to modify those values. It's in the first tab of the Drawing Settings window, here. Of course, to snap only in every point of the grid, the snap spacing and grid spacing must match. Don't forget this. And the values that I have now are the settings that I used in the previous example. Suppose we set 5 for snap spacing, but leave 10 mm for the grid spacing. The result is this, and it can actually be a good method, because with the same grid I can have the center of each square as an extra point to snap, as you can see. To have a different x and y spacing, I need to uncheck equal x and y spacing, and then I set the values. Here I have 5 mm for y distance and 10 for the x distance. I can also change the length of the major lines. The higher the value, the easier to measure larger distances. If I'm zooming out the workspace, at one point the grid resizes, in a way that the lines won't get that close. We couldn't see anything if that would happen. This means that at this moment the spacing here is not what we put on the settings. Be careful, don't draw anything now. Always draw in the maximum zoom. And in the case that you want to draw bigger objects, simple, just change the spacing settings to bigger values. If I like to have the workspace more organized and I want a point to be in the corner of an intersection when I zoom out a lot, like where I am now, simple. Place the cursor there, in the corner, and zoom in slowly, keeping the cursor in the same position. When the grid doesn't resize anymore, it means that the grid is now resized correctly. Change the grid colors. As I told you previously, the default grid colors are dark. But I understand their point. We don't want the workspace to look a mess with the grid on, especially when we have lots of layers with different colors, like in the example here. But I think that putting the grid a bit lighter, it doesn't interfere that much. So let's learn to do it. To edit the colors, we have to access the Options menu. Then I go to the Display tab and click on this button that says Colors. Here we can change the color of each element on the workspace. You can see a big list here. Also, they are grouped by context. It's the list on the left. Now it says that we are at a 2D model space. So I am happy with most of the AutoCAD interface colors. So I don't need to change them, except the grid, which is a bit dark for me. To change a color, click on the element, go to color, choose one from the list or click here to pick a different one. Let's say I want it a bit green, but in a gray style. I keep the cursor here, and then I drag this rectangle to choose the proper color a bit up to be more visible, and click on OK. It's done. Now I need to change the grid minor lines. To do it, I choose the same color. Then I click again and pick up a color so the cursor will be in the same position. This is good if you just want to change the color a bit and to not look very different. So I want to put the selector a bit darker, then click on OK. I apply and close the window, and now it looks more visible. So you can just choose a color that will be comfortable for you. Change the position of the UCS. Look to this situation. Here I want to draw these objects in reference to the diagonal wall. It would be hard to draw them accurately if I use the UCS coordinates on the position by default. You can see that while I'm trying to draw that line, I don't have any reference to draw it perpendicular to the wall. But no problem, because I can make the things easier by just rotating the UCS coordinates. I go to the icon, click on it, I place it in this corner, and then, clicking on the x-axis, I align it to this diagonal line. Then I can switch to ortho mode, and you can see that I can easily draw vertical and horizontal lines according to the new UCS position. Also, if I want to insert a block now, it automatically rotates. And the same happens with the grid. Then to restore the original UCS, which is the WCS, World Coordinate System, just click on the icon and then select World. Now let's have a look at the shortcut menu, the one that we can open with the right button of the mouse. Actually, most of these functions are icons located on panels in the ribbon, but sometimes it can be easier for us doing this way. Now I will make a quick introduction of what you can find here. The first option over there repeats the last command used. It's an alternative way of just pressing enter when we don't have any command active. I actually prefer to just press enter, it's much easier. Then there is a list of the last commands used. On the clipboard we find the basic tools to copy, move or cut objects to a different file. And this still works by just pressing the classic shortcuts, like the Ctrl-C, Ctrl-V and so on. For example, I will copy these objects, press enter, then I go to a different file, and just click on paste. And they will be copied exactly in the same position as they were before. But if you wanted to copy this door straight, you can use the method that I just showed you previously, by moving the UCS coordinates to the corner, then rotate the x-axis in line of the edge of the door, and repeat the process. Press Ctrl-C, and then paste it in the other drawing. And now it's straight. Back in the shortcut menu, I want to show you some options that I use quite often, like isolate objects. I'm going to select this part, and then I click on Isolate Objects, and you notice that all the other drawings disappeared. To revert these changes, just click on End Object Isolation. In the same submenu, there is also Hide Objects, which will be the opposite. If there are parts that you are not using at the moment, you can hide them temporarily. A bit down the list, there are the options to use the pen, zoom, or the steering wheels. Then there is the Quick Select, Quick Calculator, also available on the ribbon, and the Options menu. Also, don't forget that when you select objects, that menu is different, and depends the kind of object that you select. For example, in a block, you get options to edit a block, reset a block if you modify it, or edit a block in place if you don't want to open the block editor. Then you find the basic commands to modify objects, so it's also possible to access them from this list. Then there is the draw order, and this one I use a lot. When you create a new layer, AutoCAD puts the objects of that layer above everything that was created before. For example, here I created the layer for the dimension lines after the layer for the walls. And because I don't like these extension lines above the walls, let's sweep the order. And for that I need to select all the objects of the layer dimensions. And I can do it from the Quick Select, choose the layer DLI and click OK. Now that all the dimensions are selected, I can go again to the right-click menu, go to Draw Order and choose Send to Back. And look that the walls are now visible when they overlap dimensions. Another tool I sometimes use is Group Objects. Let's say I want to group this floor plan, but without the dimensions. Turn off the layer DLI. Then I select everything and from the menu choose Group. And I could move or copy this house elevation to a different place. The option Select Similar is also very useful. By clicking on a type of object, for example a dimension line, you can see that it selects all the remaining dimensions, but yes, they must be located in the same layer. For example, in this situation, the large dimension is not selected. Object Snap Overrides has a useful tool that not a lot of people know. Suppose we are drawing a line here, and we want to connect it perpendicular with the diagonal line below. As you see, it's only showing up the midpoint and the end point. But if I click with the right button, I can see Object Snap Overrides, I go there, and I can choose a different mode. In this case, I click on perpendicular, and now you can see the symbol appearing. Just click on it to make those lines orthogonal to each other. You can try the other modes by yourself, for example nearest, or on the top you can create a temporary track point or choose the middle between 2 points. This is how it works. I choose 2 points and it selects the middle distance between them. So just explore the other modes, maybe you find some useful for you, as long as the other options from the shortcut menu. Part 3. Attributes in blocks. To define an attribute, we can either click on this icon at the Home tab, or in the Insert tab, you can find it located in the Block Definition panel. Click on it, and the Attribute Definition window shows up on the screen. Then there are 3 main fields to fill for each attribute. First, we insert the tag, which is just used to indicate the position of the attribute. This text appears in capitals, and you can't put spaces between characters, so remember this. Below, you should type the prompt sentence. For example, if I want to fill with the name of the client, I type client name. On default, I will put a value that will appear anytime that I insert that attribute. Personally, I prefer to keep this empty, except it's an attribute that uses the same text often. However, let's insert a value here. On the text settings, it has the justification on the left and standard text style. Below on text height, I specified the same as the existing text. It was 3. And remember, it's the paper height, so I don't put a tick in annotative. We click in OK, and we can specify the start point for our attribute. So now I can draw the next one, which I can repeat the process, or I could use a quicker way. With the command copy, I use the option array with 4 number of items. It's exactly what I did before. Then click here approximately to be in line with the text at the left. There are no object snap points for text objects. However, if you want to put the text perfectly in line, there are ways to do it. But it's something that we will learn later, don't worry. Then double click on the second tag, and this window shows up to modify the information that I had given before. When you are ready, click OK and do the same for the others. For the scale and date, I do the same in the attribute definition. But here the text height will be 2. Click OK and place the attribute where I want to show the scale. Then copy it below to make an attribute for the date and change the values. Okay, now that the attributes are completed, it's time to create a block with the title block and the attributes. First, I need to switch to the layer 0. Now I'm going to create a block. And first, I have to choose the name for the title. I put title block A2, so I know I have to use this block in an A2 paper. You can also create another title blocks for different papers. Click OK to select the objects, and now I have 2 options. Or I select all the attributes first and then the remaining objects, or the inverse, first the normal objects and after the attributes. I decide to select first the attributes, but I still need to click on them in the order that I want to display. This is important. Now I select the remaining objects. I can cover all with a selection area, and don't worry that the attributes are inside because they are already selected. I press Enter to return to the block definition window, click OK, and the window to edit the attributes is now on the screen. And you can see them on the order that I choose. And now have a look to the window. On the left is what I inserted for the prompts. The values at the right are what I set for the default values. As you remember, I put some values there, but actually it was for you to have a look at the appearance of this. Actually, it would be better to not write anything on the default, because now I need to erase those blanks. So let's fill with the content that I need. Click OK, and you can see how the attributes are automatically displayed on the block. Then, in this case, the drawing name is too long to fit on the box. So, if I double click on the block itself, I can edit each attribute. And in this window, you can see that aside from the attribute values, I can also change text options and properties. Just look at the tabs here above. So I changed the drawing to ground floor plan. Now let's have a look at this example. In this level point, I want to put an attribute to indicate the elevation of a specific area of a plan. But this time I want to place the text at a certain position, and for that we have to draw temporary lines as reference. So I'm going to offset this line above to 100 millimeters. Then let's add an attribute here. Click on the icon. Then on the blanks, put the tag level. Next, I'm going to type insert level for the prompt. And don't write anything on default. Just leave it empty. On the text settings, change the justification to right. You will see after. and set the text height as 300. I do this because now we are at a model space and it will be basically the triple of the distance between both horizontal lines. Click on OK. Now I'm going to put the attribute in this corner and you can see it aligned to the right, like this exactly. So you can notice when you do this way, you put the text at a precise location. So I can now delete the extra line and I'm going to use the command hatch. Let's see if you remember it. Type H and press enter. Then I go up here and select solid. Change the color of the hatch to by block, as we are going to make a block of all these objects to later edit the color of the hatch if we need. Then click on these 2/4 parts of the circle. Press enter to finish. Now I'm going to convert this to a block. Click on create a block. Then type the name, level point. Select the objects. First I click on the attribute, then on the remaining objects. Press enter again. Click on OK. Select the base point. And finally it asks to edit the only attribute that this block has. I type plus 1.2 and click on OK, and you can see the block updated. Now I can change to the layer that I want, and the colors of the hatch objects, as I set before as by block, they get the colors that I specify here at the object color. How to edit an attribute in a block. When I double click in a block reference, I can edit the attributes, but be aware that this only applies to that object. So on text options, I change the height to 200, and you can see that it updates the size of the level number. However, if I insert another block reference of the same block, let's put here 0 for example, you can see that it still keeps the previous text height. So, how could I edit the attribute inside the block? In a way, it would update all the block references. It's like this. Go to the block attribute manager, which is the icon located here. Then, in this window, I need to select the attribute I want to modify. And as you can see, they are grouped by blocks. I click on the level attribute, go to edit, and any change that I made here applies to all the block references. So if I change the text to 200, you can see that it applies to all. Dynamic blocks. This is a block reference of a window projection in a floor plan. If I click on it, I can see the base point along with other groups created by me. The one at the right is an added parameter to change the length. It's very useful because now I just type the value for a new length. When I double click to edit the block, I can see that there is this symbol here, meaning that the block is dynamic. In other words, it has parameters with actions associated. So let's start from the beginning. For adding a new parameter, we need to use the block authorities palette. If you can't see it on the screen, you can enable it in this button here. I'm going to use a linear parameter for the distance. I click in the start point and then on the end point. This distance by itself doesn't do anything because I need to set an action. And as what I want to do here is stretching the window, I'm going to use stretch. First, I need to select the parameter, then the action point, this one. I specify the stretch frame, it's the area that I want to stretch. Then I select the objects, press enter, I close the block and save changes, And now you can see how I can change the length. It's simple. So it's recommended to select the action on the other side of the base point, otherwise they would overlap each other. Let's go to the next example. Here I'm going to show you another parameter, flip, and that's what I have in this door. I can flip the opening by just clicking these buttons. Open the block editor, and then I'm going to start with this one in the middle. I click on flip, and the reflection line will be in the middle distance between frames. I could draw a line here to use the midpoint, but let's do something we learned earlier in this tutorial. Click with the right button, go to Object Snap Overrides, and then click on Meet between 2 points. Select these two, and then I can make the vertical reflection line here. Then I need an action to that parameter. And instead of going to the Actions tab, I can also click in the exclamation point to add an action. And then for the objects, I select the line and the arc. So if I close the block editor, I can see the result. Then let's add another flip, but this time to switch the door down here. This time I go to Action, I click on Flip, select the flip state 2. This time I need to select everything. And if I close the block, you can see I have a new flip to the other side. In this door, there is also a stretch action to adapt the frame to different wall widths. So let's add it. It's again the linear parameter. Choose the 2 points of the dimension line, then double click in this yellow symbol. Remember that when it shows up on the screen, it means there are no actions associated yet. There are 4 possibilities to linear parameters, so we add the stretch, then select the stretch frame, and I need to cover all this part, and for the objects, I select those here and also at the left. I press enter, then I have to close the block editor, and you can see again the result of stretching a part of a block. The parameter alignment. This parameter can be useful to align a block along a line. For example, for electrical circuits, we want to align a socket automatically along a polyline. So let's see, and this parameter is actually very simple. We click on alignment, set the base point of alignment, which I want it to be here, in the middle. Then I need the direction of alignment, which is along this direction. Close the block to return to the main workspace. Then select the socket. Click on the alignment point, which is easy to recognize as it has a different shape, and move it to the polyline. Simple. Then there are some important tips you should know. I recommend you to have the mode nearest active, so you can put the block in any position of the polyline. If your object snap is off, the alignment will not work. Another tip is that the alignment will be to the other side of where you have the pointer. For example, if the pointer is just a little bit above the line, the alignment faces down. However, if you have the pointer down the line, the block is placed on the other side. I know that this is a bit tricky, but for that reason, we can also add flip states to the block to switch the direction easily. But as we all already know, the things are never perfect in AutoCAD. At least that's our beliefs, especially when the things are not working as we desire. For example, if you have text in a block and then you want to align it here, it's alright. But if it aligns to the opposite direction, you notice that everything is flipped over, including the text. So in the case you want this socket to face the inner side of the polyline, the best is to place the block in this side and then use the grip to flip the direction. Yes, but make sure you don't have the system variable to mirror the text active. I mean, if you type mirror text in the command line, you can switch to 1 and then the text is also mirrored. Basically, if you don't want to mirror text, keep it 0. Visibility. This parameter is used to make variations on objects in a block and then display a list with different options to choose. I show to you this socket as an example. So I'm going to convert the switch to a block. And first I'm going to draw a line here to use the midpoint as my base point. Then I turn on the command block, choose a name, select the objects except the line I have just drawn, and finally specify the base point. So I converted the switch to a block. Now let's go to the block editor. And here I'm going to add a visibility parameter. I can just put it wherever I want, because its location doesn't affect the performance of the objects. Also, the visibility works with visibility states, which is a bit different than for the other parameters. If I double click here, it opens the window to manage those states. I can also access it in this button at the visibility panel. Let's continue. First, I can rename this current visibility state, type socket1. Then, let's create a new one, socket2, and click on OK. Close the window. You can see that here I have the socket 2, and as this state has exactly these objects, I leave it unchanged. Then I switch to socket 1, and here I don't want to show up the number 2. Click on it, and then press this button at the visibility panel to make it invisible. Very good. Now I go back to the visibility state window and add a new state called socket 3. If you look at the bottom of this window, there are 3 options here. And now I tick the third option, and this new state will be a copy of the current status, which is socket 1. So I'm going to add a hatch object here. And first I draw a line. Then I activate hatch and fill all this area. I also want to change the pattern to a solid color and then fill the area here. And now that I am done, I press enter. Important: when you draw new objects here, they only go to the current status. For example, if I switch to the socket 1 or socket 2, you can see that there is no hatch there. On the visibility panel, there is an icon, it's actually a system variable, to control how the invisible objects are shown. In the current mode, the invisible objects are transparent, so you can notice them. However, if you click in that button, you choose to not see them. Part 4. In this part, we will learn to use the Design Center, as well as the tool and block palettes. They are located in the View tab. Finally, in the last minutes, we will have a look at the external references, a very useful feature in AutoCAD. Now we can start. The Design Center. In AutoCAD, we can import content from different drawings. Let's go to the View tab, and at the Palettes panel, we can find this icon, the Design Center. I click on it, And on this window, we can browse for a specific DWG file. I'm going to choose this one, and then you can see that we can have access to blocks, dimension lines, layers, line types, and other elements that are located on that file. If I want to insert a specific block from this file, I click here, then select, for example, Table 1, double-click on it, and this window appears. Now, if I click on OK, we insert the block exactly in the way that it was created. But we can use few insertion options. Let's see them. In the middle section, we have the scale, and is set by default as 1 for each X, Y, and Z axis. If I click on Specify on Screen, you will see what happens. AutoCAD prompts to specify the X scale factor. I'm going to type 2, and then it asks to enter a Y scale factor. And have in mind, if it's a different value than X, that would deform the table. So, as I don't want it to happen, I have to use the same X scale factor, 2. I press Enter to place the block, and as you can notice, all the dimensions are now double size. Back on the Insert window, I can click on Uniform Scale to insert just a scale factor for all the axes. So you have a step less. Another insertion option is rotation. Put a tick on there, click on OK, then this time I put for the scale 0.5, and then I'm going to rotate it 90 degrees on this direction. So it's simple, as you see. Finally, there is also another and important information here. The block unit, which for this one is set as millimeters, and I cannot change it, as you can see. Actually, the unit is defined when we create the block, here on the bottom left corner. I think a lot of people don't notice that, even usually it's not a problem. But what's important to know is the unit that appears here by default is what is set on the unit properties for the insertion content. You might remember this when I explained in the tutorial for beginners when we insert content from a different file, and that's exactly what we are doing here. Let's now have a look on the next example. I'm going to change to this file where I have several door blocks. I'm going to choose door 1, and this time you can see that the block unit is set to inches. As in my current file the unit is millimeters, the block has to be converted from inches to millimeters, and the conversion factor is automatically calculated here. It says 25, but is it correct? Do you remember, if you look at the tables, 1 inch is 25.4 millimeters. But it shows only 25. Why? Because on the unit properties, I have this option set to not show decimals. If I change it to 2 decimals or 1 decimal, now you can see 25.4. It could be 25.40, but it doesn't show the zeros at the right of the comma, because there's no need. Since AutoCAD 2020, there is a new palette to insert a block from other drawings. It can be quite useful. I click on it, then I need to click on this ellipsis to find a different file. And here you have the blocks within that file. This is a nice feature. It's faster to search for blocks, and also you have in this panel tabs that group the blocks from other drawings, recent blocks that you used, and the blocks from the current drawing. It also indicates which blocks are dynamic. Now to insert a block, it's easy. Double click in the one that I want, go to the drawing, and it just asks to specify the insertion point. You can see here that is the only option ticked. The disadvantage regarding the design center is that I cannot see the unit that the block was created. Anyway, I don't think that's a big issue, as I can always check it out on its properties, and if you notice that it's not in the right size when you insert a block, you can simply apply a scale to it. So, among the elements on the design center, we can also add layers from other drawings. It's very simple. If I want a layer from this file, Centro de Exposiciones, I just need to double click on the one that I want and it's automatically added. You can see the new layer Arcos Vista. To import more than one layer, I select them, and this time I do not double click. It doesn't work this way. Instead, I click with the right button and choose Add Layers. Here you have them, and remember that in the layer properties, the layers are displayed in alphabetical order. For dimension styles, it works the same way, simple. So you can play around this with the other elements, and you will notice that they work all similar. Tool palettes. It's this icon here. This is another way to insert content from different drawings. I think this is something really useful in AutoCAD. Basically, it's a kind of library that organizes items into these different tabs, which are called palettes. All these items here come by default in AutoCAD, and they are located in sample files. If you are curious, those sample files can be found on the AutoCAD folder. Go to Samples, and all the default DWG files are there. There are dynamic blocks, normal blocks, hatches, or other kind of objects. Let's open one of these files, for example, Home Space Planner, and you can see that there are just blocks here. And actually, we can get advantage of these files, because we can use those blocks in our projects without the need to search for blocks on the internet. These are also more sample files. Now let's go back. On each palette here you can find specific elements. Blocks for architectural, annotation, mechanical, electrical, civil, and so on. To insert an element or object, just click on it and click again in the drawing. It's very simple. The only thing is that you don't have insertion options here. It uses the ones by default. You can also insert a hatch. For example, I click in this dark red and place it there like this. But be aware, this doesn't create any layer. If you look at the hatch tab on the ribbon, it just uses this specific color for this object, and it went to the layer walls, as it's the current layer. Okay, now I'm going to show you how to organize these palettes. If you click here with the right button, you can use the palette group that you desire. For example, there are the parametrics here. If I click in Civil, it shows this one, and so on. Look that there are also tables, or even visual styles. Then these palettes can be customized. If you click with the right button, and then go to Customize Palettes. On the left side you can see all the palettes, and on the right the palette groups. Each group contains how many palettes as we want. Some just have one palette, and others, like the annotation design, have several palettes. As you guess, all these can be customized. Just click and hold in one palette, for example modeling, and drag it to a palette group. I put it on Annotation and Design and at the top. The order here indicates how the palettes are sorted on the Tool Palettes main window. Okay, but actually I don't want this palette here. So to remove a palette, click with the right button and click on Remove. Now, I want to show you how to add new palettes, for example, with blocks from other drawings. What we need to do is to use the Design Center to bring content to the tool palettes. So I have the Design Center window here, and I want to add the blocks from the files that are in this folder. If I click in any file with the right button, there is an option here to create a tool palette. Click, then wait a few seconds until the palette is generated, and as you see, it goes directly to the top of your current group, and also only the blocks were generated. Then I'm going to repeat the process for the other files: doors, home assembles, kitchen, and windows. All are generated and placed above. Back on Customize Palettes window, I'm going to add a new group named My Blocks. And then move the new palettes to this newly created group. When ready, I can also remove these palettes from the group Annotation and Design as they are not needed anymore. Select the palette and press Delete. Finally, switch to My Blocks, and here you have the palettes with this nice organization. So you can see, at least in my opinion, this is a very practical way to use blocks in your projects. And it's also possible to choose a specific block from one of your lost files and put it directly on the palette. Now, I encourage you to create your own palettes, and you will see how organized your projects become. External references. I open a new file, and here I want to attach a reference to a file that it was previously given to me. This one, Project Architecture. Imagine that I am a structural engineer and I want to draw here the structural plan. Or I could be an electrical technician and I want to draw electrical circuits there. So, on my new file, I go to the Insert tab, and on the Reference panel, this is the panel that controls references, click on this arrow to open the External Reference palette. An alternative way is typing the command xref, or external reference. At the moment, I just have here the current file. You can recognize it by the DWG icon. Then, if I switch to Project Architecture, now you can see that the current file changes. It also has an additional element, which is an attached image. The details of each file you can check out on this part below. This is a JPG file. That image is the one that I added to the title block on the Layout tabs here. Then, if I click on CAD in Black logo with the right button, I can detach the image in Unload, and you can see it disappearing. But I don't want to do it, so I click again with the right button and click on Reload. So, to attach here the file Project Architecture, I go to this icon, then I click on Attach DWG, select the file. In this window, I click again on OK or specify the insertion options that I want. At this moment, I'm not going to scale the reference, the option specified on screen is not ticked, and I specify the insertion point. If you remove the tick on this box, the base point will be on the coordinates specified below, and if it's 0, 0, 0, the base point will be on the origin. Click on OK and place now the base point where I want. I'm going to put the coordinates in the origin
So I type 0, press Tab, 0 again, and press Enter. So here you can see the reference to the project architecture, and it's easy to recognize because it's darker than usual. At the file references list, you can see the new attached file, the DWG, the project architecture, and the image that was in that project is also shown here. And it appears with the name of the file first, and then the name of the image, the CAD in Black logo. However, sometimes for any reason, some of the files attached might not load because the program can't find the file. And even if you click on reload, nothing happens. So the solution for this is clicking on change path and search for the file on your computer. How to edit an external reference in a drawing. If I click on the image, you realize that everything is selected. I cannot select a line by line or an object by object. Also, on the ribbon, it shows up a new tab called External Reference. Here I can create a clipping boundary on a part of the drawing and other options. Example, let's say in this project I only want to show the floor plan below. I click on Create Clipping Boundary, then I select Rectangular, draw a rectangle around the drawing, and all the other parts of the file just disappeared. I can also invert the part of the drawing that is showing by clicking on this grip. Now let's use a different clipping boundary. I'm going to click on Polygonal, and it could be useful if in a different case I would like to select this drawing below or the drawing above and not the one in the middle. So, the purpose of using external references is to allow 2 or more people working in the same project. Now, let's suppose I have a specific task in this project. Look to the layer properties. Now they are a bit different as I'm using external references. On the filter section, I can choose which type of layers that I want to display. The layers on gray are from the external references. First you can see the file name and then the layer name. For example, at this moment I have all the layers shown on the screen. Now I switch to the all non-XREF layers, or I can see only the layers from the external reference. So, it's not hard to work with external references, as you can see. But I recommend you to practice a bit to interiorize all these steps that I have been showing to you. Part 5. We are going to discuss here multi-leaders and the Properties panel. Multi-leaders are an interesting way to add annotations to our drawings. They consist in an arrow that connects to a text or a block with an attribute. Let's have a look to it a bit more in detail. We can add a multi-leader from the Annotation panel at the Home tab, or if we switch to the Annotation tab, there is a full panel dedicated exclusively to leaders. The first thing I should do is check out the settings by clicking in this arrow here. So it opens a window very identical to the Dimension Style Manager. Let's select the style, the standard one, and modify it. Here I'm going to start with the text height, and because it's too small, I'm going to change it to 250. As my text labels are 350, this will be just a bit smaller. Then on leader format, I want also to change the style of the arrowhead, for example 200. On leader structure, I have by default 2 leader points. Then uncheck the box for landing distance, if I don't want it to be a fixed value. I click on OK to confirm the changes and close the window. So now I can add a leader. it's easy, just click on the multi-leader icon, choose a base point, then specify the leader landing location, and click one time more to type the text. For example, external wall, as it's what the leader indicates. Then change here the layer style to annotative. Nice. This time I'm going to repeat the process, but instead I'm going to add an annotative multi-leader to appear in this viewport in the scale 1/100. Change here the layer style to annotative, and then on the multi-leader style manager click on modify. So I will not change the settings because I think they are quite acceptable. I close the window. Don't forget to make sure the scale is correct, 1/100, and draw the multi-leader. For example, window. Now if I double click on the arrow, I can see the quick properties of the multi-leader. For example, let's change the landing distance to 10, and you can see the distance updating automatically. So if I switch to the Layout tab, I can see how the annotative multi-line looks like. Multi-leaders have two types of content, multi-line text or a block with an attribute, which it's this example here. Now I'm going to show you how to make this. Go again to the multi-leader style manager, and here I'm going to create a new style. I select this time annotative and click on new. So my new style will have the same settings as the annotative style. Choose a name for it, and when I'm ready I click on continue. On this window we go to content and change the multi-leader style to block. In this list, as you can see, there are already several blocks for multi-leader that come with AutoCAD. Apart from this, I can also use a block made by me, but this time let's use this circle. Then I can change the scale, but I'm going to keep it 1. Have in mind that in this kind of multi-leaders, using a block, we don't specify the height of the text. Then I create a multi-leader somewhere here, and as the text inside the block is an attribute, I'm asked to insert a value, let's put 1 for it, and click on OK to confirm this choice. Okay, I don't like too much this position, so let's use the grips to put it a bit here inside. Now it's good, and you can see that it has an acceptable size on the layout. Let's add another multi-leader, and this time I put 5 for the value. You can see how simple it is. One disadvantage in multi-leaders: unlike dimension lines, if I change the multi-leader style settings, the existing objects do not update automatically. So if I decide I want to change the block, I have to draw them again. As you see, I inserted the arrow with the new block. On the next example, I'm going to add a multi-leader using a standard style, non-annotative. So, if I use the scale 1, it will be too small for the drawings that I have here. I need to increase it. Let's try with 20. Then I close this window. I'm going to draw the leader. And you can see that the block I have here is a bit different. This one has 2 attributes. I just put random values, and now the size fits quite well for this drawing. Have in mind that using the blocks by default in multi-leaders can be hard to measure exactly. Actually, what happens is, the measurements themselves are defined at the block editor. When I specify the multi-leader settings, I can just set the scale. Each multi-leader can have more than one arrow. If I click on Add Leader, then I select the multi-leader, I can add an extra leader. So this is as simple as it looks, and it's possible to add how many leaders as I want. I could place another from this point, or press Escape to cancel the command. To remove a leader, just click on the icon located below, select first the object, and then click to remove the arrow. Now let's talk a bit more in detail about the properties of objects. You can find an entire panel here. As you can see, there are three main tabs. The first is for the color, the second the line weight, and the third the line type. By default, these settings follow the properties of the layer where the object is. Now, suppose I want to change the color of only a certain object. I click on it, go to the color tab, and change it to red, for example. So, at this moment, the color of the object is not regulated by the layer color. Next situation. Now I have a block. And you will see that they can act a bit different. If I try to change the color, you can see that it doesn't work. And as you remember, we should put the lines that form a block in the layer 0 before creating it. So I'm going to copy this block, and then I use the command explode to return to its original objects. If we want to give more freedom to the block before creating it, we set the color of the objects as by block. Then I convert the door to a block. I finish. And as you can see, it's possible to change the color to follow the layer or choose a specific one like I did before. There are also several ways that I can play with colors in blocks. For example, I can set the color of these two objects to an orange. Then I create a block. And what happens is that when I change the layer, those two objects will always keep the same color. Line weights. I'm going to select this line and change the line weight here to 1 mm. But nothing seems to change. Why? The line weight at the status bar is switched off. So I need to switch it on to see it. If you don't find this icon there, go to the corner, click in these three lines and find it on the list there. Also, look that the weights measure exactly how they are printed. 1 mm, and no matter the scale that we are using. So basically the line weights are annotative. Now I'm going to switch off the icon Show Line Weights. And now even the line looks similar as the others. Also, it's not displayed on the layout. It's still there when you print a project or publish a PDF. Here you have it. And now you can ask, why does not AutoCAD show the line weights by default? Honestly, I'm not sure about the answer, but I think it's to not have the workspace too messy with different weights of objects, especially if there are lots of them. Basically, it's up to us to decide if we want the line weights or not. Like line weight, there is a similar option to add a thickness, in this case for polylines. I can use the command pedit, it means polyline edit. I select the polyline, and you can see several options to use here. For example, I can turn into a spline, or click on the curve to come back to the original polyline, along with other options that you can explore later. If I click on the third option, I can add a width. Then it prompts, specify a new width for all segments. This time, this width value is a real size, like when you draw standard dimensions or standard text. So let's type 50 and the polyline has this new shape. I can still snap to the object snap points, and they are now in the middle, because when we add a width to a polyline, it basically expands to the sides. Extra tip. If I wanted, I could draw a wall just using one polyline with a specific width. For example, let's draw this rectangle with 5 meters per 2 meters. Then I right click, and this is a different way to access the settings that you can find on P-Edit. I select width and put a thickness of 150. So this could be a wall. However, look what happened here in the corner. It looks like that these joints are not connected. And this is because the polyline is not closed. I open again the right click menu, and this time on polyline, I click on close to have the result that I want. Now let's talk about the remaining setting, the line type. I'm going to select this line, then I click in this tab to select the line type. In this case there was already a dashed line selected, but let's see the others. Then click on load, and you can find a bunch of line types in this list here. Let's choose this one, click on OK, select it again here. Then it didn't change. I also have to select the line. And now yes, it changes to the one that I want. Now let's go to the properties. There is a parameter very important here, is the line type scale. And we have to play with the numbers to know which range of values we need to put here. Another thing, you can also notice that the current value is 0. Of course, it's not possible to have a scale 0. But the reason of this is, on the unit properties, I have the precision set to no decimals. I'm going to change it to 2 decimals, and you can see that actually the current scale is 0.1. Now let's see how the line type scale works. The smaller it gets, the more difficult it is to see to distinguish the shape. The larger it is more likely to see just a continuous line or zooming into a gap. Let's see another very important tip. It's common that we want the line types to appear in a specific viewport. So, as the viewports are in a specific scale, this one is set as 1 per 100, we should set up the scale in the model space before choosing the line type. If we do this, the line type will look exactly as it is in the viewport. On the other hand, if my scale is set to 1 per 1 and choose the same line type, this is the current appearance at the model space, when I switch to a viewport that is scaled differently, 1 per 100 in this case, I can see that the appearance will not be the same. So, we reached the end of the tutorial too. Now I think you have enough knowledge to practice yourself. Remember that you can find a playlist with exercises in my channel page. It's really important to practice. Then, when you are ready to learn more tips in AutoCAD, you can watch the next tutorial, which starts right now. Hi again! So this tutorial is a continuation of the complete tutorial for intermediates that was playing right before. Let's check out the contents. First, I'm going to focus on the status bar, and then I will explore more the topics dimension lines, lines and polylines and other drawing commands, and tips for texts. Let's start. In this first chapter, I'm going to focus on some functions of the status bar that I haven't explained before in the previous tutorials. I will start with the isometric drafting, and to understand how it works, we are going to draw this simple cube which is represented as a 2D isometric projection. There are 3 different planes that we can work on, the left, right and top. And before starting, let's switch on the grid, and you can notice when I turn on the isometric drafting for the left plane, the cursor and the grid are automatically readjusted. And the same happens with the snap mode and the ortho mode. However, the polar tracking doesn't work for isometric drafting, and that means you should be in the ortho mode to use this technique properly. Okay, let's make the cube. I start with the left plane, and this time I'm going to switch on both the grid and the snap modes, even they are not required, to help you visualizing the drawing process. I'm going to start in a major intersection, and then make the edges, each of them measuring 200 millimeters. So, when I'm done with this face, I change the plane to right, and you can see how easily it's now to draw the right side. This time I switch off the snap mode because I don't need it anymore. And finally, I turn on the top plane to draw the remaining edges. Now you can start practicing ISO drafting in your projects. Annotative scaling. Now, in this drawing I have added annotative dimensions in different scales, 1 per 50, 1 per 10 and 1 per 2, so they appear in the viewport that has exactly the same scale. As at this moment the annotative scale is 1 per 1, no dimension lines are shown here. However, if I activate this button, all the dimension objects appear now in the workspace. Basically, when this icon is off, I can only see the annotation objects that match the current scale. The next icon, Add Scales to Annotative Objects when the annotation scale changes, has the following effect. If I change the scale, each dimension line was added to that scale, and they will still appear if I change one of the viewports to the scale of 1 per 5. The gear here that looks like a settings menu is actually meant for switching the workspace. By default, AutoCAD comes with 3. The current one is Drafting and Annotation, which is used for drawing in 2D. Then we have 2 workspaces for 3D modeling. First, we have 3D Basics. This one comes with simple commands in the panels for drawing 3D objects. And as you can notice, the buttons here are bigger than in the other panels. Finally, we have 3D Modeling, and here the panels and menus are more complex, with plenty of commands to model our projects. Then, if we are not happy with none of these workspaces, we can create a new one in Save Current As, and then customize it here in this option. Finally, if we put a tick here, we can display the workspace name in the status bar. This button, which represents a square, a circle and triangle, is for isolating or hiding objects, and it's very simple to use. Let's start with Isolate. Then I pick these 2 objects, press Enter, and as you can notice, everything is hidden without this part. On the other hand, if I click on Hide, I can hide some objects from the screen, and I'm doing it on these 3 ones as an example. To return to the normal state, I click on End Object Isolation and everything is shown again. Hide and Isolate can be especially useful when in a complex project I want, for example, to make some changes in this specific section. Here, I have decided to isolate this part and then hide the lines that I don't need. One last tip. Alternatively, I can access these options from the right-click menu, and it's exactly the same as what you can find on the status bar. The next icon is the Autodesk Trust DWG. This function analyzes if the current DWG file was last saved with an Autodesk project or by a software developer licensed to use the real Autodesk toolkit. If it matches this criteria, you will have a green tick here. If not, you'll get a warning instead of the tick, and Autodesk cannot guarantee the application compatibility or integrity of the file. In other words, if you were working in a DWG file in a different CAD software, it may work properly here in AutoCAD, but it's not 100% guaranteed. The next button is called Clean Screen, and we just use it to switch to the full screen mode, like this. This can be useful if we want to work in a wider workspace. So, click on it again to get to the previous state. Finally, we have Customization. Here, we can add or remove icons to the status bar as we wish. Some of those used to be included in the status bar by default in previous versions, and that was the case of the dynamic input. I'm going to check this option, and you can see it appearing just before the ortho mode. Also, have in mind that the tick doesn't mean the function is turned on, only that it's displayed in the status bar. So, this function shows the input next to the cursor when I type anything with the keyboard, such as a command name, length, etc. And look that it's not showing it anymore when it's off. Another function you can add to the status bar is the selection cycling, and this one is very useful for complex projects. Let's switch it on. And basically, when I click on two objects at the same time, I mean when they are overlapped, this window shows up so I can select the object that I want. By default, it selects the one in the front, and in this case is the construction line. But if I want the line that's on the back, I simply click here and it's selected. Now this is important. If you zoom out a lot and click in a place where it's busy with objects, for example here, look that the window shows up a big list that you can choose from. In this case, most of these objects are not necessarily overlapped, but they are close enough, so they still appear in the list. Okay, in this chapter, I will explain some extra tools for the dimension lines. Let's start. Continue and baseline. On the next example, suppose I want to add more dimension lines to measure the remaining distances along this side. Instead of creating dimensions one by one, there is a very useful tool that can save you considerable time if you are working on a huge project. The continue dimension. First, I'm going to draw a vertical dimension here. Then, I'm going to push this button that says continue. And suddenly, it looks like I'm making another dimension in the same direction as the last one that I created here. So, as you can see, it's easy to place several dimensions by just clicking on the points that we want. When you finish, just press Escape. I also want to explain you a tip. As this command defaults to continue the last dimension, I need to click on Select to change to a different dimension line. For example, I click in this one if I want to continue it to the right, for example. Below the button Continue, we can find Baseline. With this feature, we can make several dimension lines measuring a distance from the same point. Also, look that the precedent is the same as for the Continue command. However, there is a specification that's a bit different. The spacing between each line must be defined on the Dimension Style Manager. I'm going to modify the current style, Internal Measures, and on the Line section, we can change the baseline spacing. Let's increase it a little bit to 5. And then click on OK. Okay, nothing has changed here. In fact, the new spacing only applies for the next dimensions that I will draw. I'm going to delete them and repeat baseline again, and look that the spacing is a bit wider than before. Another tip regarding baselines is about the position of the dimension. It's curious that if the pointer is below the line and the text, the new dimension will stay above it. And if I move the cursor to the other side, you can see that I'm switching the position of this new dimension line. Have a look at this example where you can see some dimension lines intersecting each other. In order to avoid them appearing as normal lines, we can add dimension breaks at their intersections. The icon is this one, and the way this works is really simple. I just need to click on a dimension line, press Enter, and the break is added automatically at each intersection. Now let's activate the command again. Another way to access it is by typing dim break. And this time I select the dimension 600, and as you can see I broke it at these two dimension lines, but stays continuous at this point, because a break is already added in the previous dimension. Also, breaks apply to any kind of objects that the dimension line intersects. And to show you this, I'm going to repeat the command in this drawing where this dimension line intersects those circles. Look, there is a break in all the intersections. To edit the break size, I just need to go to the Dimension Style Manager, modify the style Dims for exercises, the current one, go to the tab Symbols and Arrows, and at the bottom you can see the section for the dimension break where I can change the break size. As an example, I'm going to set 10, click on OK, and now as you can see the gap has increased. Dimension space. At the right of the icon Dim Break, we can find Dim Space. When the dimensions are not well organized, or we just want to set the same spacing between different levels, we can use this command. The process is the following. First, I need to choose the base dimension, which is the one that will not move. Then I pick the dimension to space. Let's select this one with 200 mm of length. Press Enter, and then I can type a value or set an automatic spacing. If I press Enter again, you can see the second dimension goes down, and now the spacing between both matches the extension lines of the first dimension. Okay, now I'm going to undo this pressing Ctrl Z and repeat the command again. I select the same base dimension, but this time I pick up these two. I use again the auto spacing, and now the three levels are separated equally. Let's go back one last time. I'm going to do exactly the same, but now instead of automatic, let's type a specific distance. For reference, I can look at that small dimension of 20 mm, so let's put the spacing a bit wider. I think 30 is fine. Now this is how it looks like. Create a jog dimension. This new example has a section at the right which is long enough to not fit in a paper. And this representation means that this length is larger than what it looks like here. So I'm going to add a dimension line, but this time let's use the tool Continue. Then pick up this last dimension and place this new one here. Now the length of this dimension line is 300 mm. However, the real size of that section is 1500. To represent that, I need to add a jog dimension. The button is located here. And this is simple. First I click on the button, then select the dimension line and click exactly in the place where you want to add the jog. Now to replace the current measurement, I can simply double-click on the text and change the value to 1500. Basically, what I'm doing here is adding a text override, and it can be either as a text, numbers, or both. Finally, select the dimension, click with the right button, go to Quick Properties, and there I can see the real measurement of the dimension, which I cannot change it, is 300, and the current text override. Now, to display the real dimension length again, you can just erase the text override. It's also possible to edit the size of the jog in the Dimension Style Manager. I'm going to modify the current style. In the Symbols and Arrows tab, there is a panel called Linear Jog Dimension. Here, we have to specify a height factor with the text size. As it's currently set as 1.5, you can see the size of the jog a bit bigger than the text. And if I change it to 3, click on OK and close the windows, you can see now the jog increased to 3 times the size of the text. Okay, now let's have a look at extra tips to apply to dimension lines. Draw the dimension line at a specific distance from the object. Suppose we have this example and we need to add dimensions to indicate the lengths of these lines. In fact, that's easy to do. We just need to activate the command Dimension Linear, click on 2 points, and finally click again to place the dimension line, right? Okay, now I'm going to do the same, but for the left side. And also let's add a horizontal dimension here in the bottom. As you can see, the dimensions are correct, and there is nothing wrong with them. But as you can notice, I used a random distance from the lines for each of the dimensions. Okay, maybe it's not a big deal, but in my opinion, it's better if we use a specific dimension spacing for the entire drawing, or even for the full project. Let's see, I'm going to do this again. This time, I'm drawing a dimension line measuring this section. But then, instead of clicking on a random location for placing the measurement, I decided to have it, for example, at 500 mm above the line. And when I see this extension track line, I type 500 and press Enter. In this way, I will have that distance between both objects. Then, for the left dimension, I use the same method. I hover the endpoint, drag to the left and type 500 again. Finally, I repeat the same process down here. Type the 500 mm. And now you can see that all the dimensions have the same separation between the lines, making the drawing looking nicer. Of course, there are always exceptions in a rule. Let's use the command continue for the dimensions above. First, I have to choose to select the object that I want to continue. I click on select, then on this extension line. As you can see, I am adding another dimension connected with the first one. And finally, add a third dimension by clicking in this last corner. Of course, as you can see, this last dimension is far away from the line. But in this way, I can have all the dimensions in this side all along the same reference line. Finally, here you have an example of this method applied in a floor plan. Set specific lengths for extension lines. Another nice setting is to set a fixed length for the extension lines, those bars that limit the measurement. Using the default settings, when I add more dimension lines all along this side, and look that I can do it pretty quick by just clicking in each intersection, they start from the points where I click with an offset gap that is also specified in the Dimension Style Manager. I'm going to access that menu by clicking on the icon located on the Dimensions panel. Select the dimension style, this one annotative, and click on Modify. In this section below, Put a tick here to add a fixed length on all the extension lines. As you can see, the length here is 3 mm, and actually, as this is an annotative style, this value means that the extension lines will measure 3 mm in a paper after printing it. Click on OK and you can see the result. Use template files with your own dimension styles. This is a good practice if we want to keep the dimensions with the same appearance in all the projects we are working on. Suppose you have a file about the project of the building X, then your next one will be about the building Y, and then the building Z. As you will probably use different DWG files for each project, to keep the same dimension styles, the best is to have a template and use it whenever you start a new project. So, in a new file, which can be from a template you have created, and I don't have any objects here in the workspace, I'm going to the Dimensions tab on the Annotative menu and click on Manage Dimension Styles. So these are the default styles. I can modify any of them or create a new style if I want. And that's exactly what I'm going to do. I click on New. Then, on the first blank, I should write a name for the new style. Start with means that I copy the settings of the style that is showing here. In this case, annotative. Below, I decide if I want to use annotative dimensions by checking this box. And finally, I can continue. So now we can make the changes that we need. Text, arrows, primary units, etc. I'm going to add just a suffix here as the symbol of millimeters, because I put it on the title. And click on OK to save the changes. After, I can add more styles. For example, let's say I am creating a similar style with the same settings, except for the suffix I'm going to set meters. And for that I put a scale factor to convert millimeters to meters. Of course, this is in case I'm making the drawing in millimeters. And when you are ready with your styles, let's save this file as a template. Choose the name and save it on the default templates folder or create a new one. In this way you can start your projects with the same template and you don't need to edit the dimension styles again. On the next chapter of this video, we will go back to lines and polylines, but this time we are going to learn some interesting tips that will help you to master these two commands. Let's start with settings to edit in a polyline. There are several features we can edit in a polyline, and we are going to start with close. To explain you this situation, I'm going to use this example where we are going to draw this simple figure with the command polyline. You will see that what matters here is the way we will draw the last line. Let's activate the command polyline. As you may know, I can click on the icon at the ribbon, or a faster way is using its alias. Just type PL and press enter. Then I'm going to draw this irregular polygon and let's make it beautifully starting at the same horizontal plane. First, make sure Object Snap and Ortho Mode are on. The snaps are off. Let's turn them on. I'm going to hover this endpoint, drag to the right following this track line, and then I type 200 mm to start a polyline at that distance from the corner. Then I draw each line by typing the exact length with the keyboard. And to make the things easier for you, you can just look at the left drawing as all the dimension lines are there. Also, notice as we are in ortho mode, all the lines snap vertically or horizontally. And in this way, we can draw all the lines much faster. I'm going to speed up the process. And when I arrive at the last line, I'm going to finish the polyline normally by clicking at the endpoint. What happens is, if I'm using the grips to modify the figure, by trying to move the line at the bottom a bit down, where we should click on this grip at the middle, you can see it separates from the last line. In contrast, what happens if I try to do the same in these other segments? Look. However, let's go back. When we want to join the last line with the start point, we can click on close or typing CL, and this time I basically remove any start and last point from the polyline, and the lines no longer break at the origin. Now I'm going to select the polyline and right-click with the mouse. Let's go towards polyline, and there are several settings that we can do here. If I click on open, look what has happened. The last segment that I inserted just disappeared, leaving the polyline open. Instead, if I click on close, I get back to a closed polyline exactly how it was before. With the options at the bottom, I basically convert the polyline into a spline. If I choose Curve Fit, you get this result, and it's exactly like drawing this figure using the spline fit command. On the other hand, if I convert the polyline to spline fit, it uses the method of drawing the spline CV command. I know it sounds a bit counterintuitive, but CV actually means control vertices. In the same menu related with the polylines, we can add a width in case we want to represent that polyline a bit thicker comparing with the other objects in this drawing. Then we are prompted to insert a value. Because I have these dimensions here as a reference, I can guess more or less how the new thickness will look like. Let's insert 10, and it should be more or less this distance. Type 10, press enter, and here you have the result. One characteristic when you add a width to a polyline is when you select it, the grips are located at an imaginary line in the middle. To get back to the previous state, I go again to width, but this time I'm going to type 0 to disable this property. Convert lines in a single polyline. Sometimes we are just drawing something, and only after finishing we realize that we have been using the command line instead of polyline. That's fine, and there is no need to draw everything again, of course. There is a command for that, the command join. You can find it here on the Modify panel. That's simple. Select all the objects and they convert to a single polyline. Line types. A lot of AutoCAD users have encountered problems when dealing with line types. In addition, the way they appear in the workspace can be very different than in viewports on the layout tabs. All that strolling is due to the line type scale. So, in this tutorial we are going to explore this step by step, hoping this won't be a big issue for you. Back on the same drawing, we are going to create a new layer here. Let's name it Dash Lines. And set a different color, for example this light blue one. Next, I select the drawing at the right and change it to the new layer. On the Layer Properties Manager, there is a column about line types. Let's change the line type for this layer. And first I have to load a new one. And as you can see, there are lots of them that AutoCAD provides by default. I select this ISO-space. Then don't forget to select it also here. Click on OK and close. As you can see, the lines in that blue layer are now dashed. Now, there isn't any control to set a measure of each dash or to set the quantity of dashes within a line. That would be very hard to measure, but what we can do instead is set the line type scale. Now in AutoCAD, we can set a line type scale for a specific object, or we can apply it generally for all the file, and in that case all the lines that are not continue change their appearance. So to set the general line type scale, I type LT scale and press enter. The default value, as you can see, is 1, and this drawing has the dashes with this size. If I change the scale to 0.5, you can see the dash sizes are now half smaller. If I am not happy with the result, I can keep changing until I find the size that works for me. So, at this moment it doesn't look hard, but suppose now I draw a line very large in comparison with the existing objects. What happens here is, with the same line type scale, I cannot see anything. As I don't want to modify the other dashed lines, I can do a different process. Select the line and go to Properties. And here you can see a setting for the line type scale. By changing this value, and this time I'm going to try a very huge one, for example 50, and let's see. Finally, I can see the dashes properly without changing the lines that I have in the exercise that I showed you before. Now let's go back. But they seem to change. Okay, this is actually just a problem of loading the screen. Usually if you zoom the screen few times, we'll solve this problem. But in this kind of situations, the best is to use the command regenerate. And now the dashes are visible again. Object snap overrides. Midpoint between 2 points. Imagine we are drawing a polyline or a line. Here, the next point will be on the midpoint of this distance. Normally, we would make a temporary line there and use its midpoint. That's a way. However, there is an alternative. If I right-click, go to Object Snap Overrides, select Mid between 2 points, then you will see, if I click on 2 points, the line ends at the middle between them. Use the specific Object Snap mode. Sometimes you have probably noticed it's hard to find the mode we actually want, especially if a lot of them are turned on. For that, you can go to OSnap Overrides and choose the one we want to use right now. For example, if I select perpendicular, it's very easy to find a perpendicular intersection to this line. Okay, let's go on. Now I am going to show you extra drawing commands that you can find in this little section. Let's start with spline. It's a command to create a smooth curve. And there are two types. The first one is spline fit. Here we choose the points where the curve must pass through. And when you finish, press Enter to confirm the spline. If you press Escape instead, you cancel the command and nothing is created. So have this in mind. Then, it's possible to adjust the position of the curve by moving the grips. The second method to create a spline is with controlling vertices. Now, unlike the spline fit, the curve doesn't pass through the points that we specify, as they are just vertices to control its position. Then this grip that looks like an eject button switches from fit to control vertices. So you can use this if later you change your mind. Another command available here is the construction line. It's this button. This creates an infinite line and it's used mostly for drafting purposes. One of the situations they can be useful is to draw an elevation of a floor plan, like the example I'm showing to you right now. The next command at the right is called ray, and it works in the same way as the construction lines. As well, we can use them as a reference to draw other objects. The difference: a ray is a semi-detached line. It has an origin and continues infinitely in the direction that we specify. Also, the polar tracking might be useful here. If we need to create rays separated equally with a specific angle, for example 15, select that option and then click where the pointer snaps. Other type of reference is simply a point. I can click in this command, multiple points, and you can place them in strategic positions. Then in this example, I'm going to add 2 points in 2 intersections of the track lines. At the right, we have 2 buttons called Divide and Measure. They are very similar. With Divide, we can create a certain number of spaced points along a line or another kind of object. Now I enter the number of segments, for example 5, and press Enter. The only thing here is that we can't just see these points if we delete the line or move it to another place. So in conclusion, I think this command can be useful if we need to place equally spaced points along a certain direction. So in this case, I can draw a line, then use Divide, and erase the line at the end. With the command Measure, instead of specifying the number of points, I set the length between each of them. As an example, let's type 20, and I divided the line in 5 sections. In the last chapter, we will talk about texts, and this time we will focus on some a bit more advanced tips. Let's check them out. Insert text height is not showing on the command bar. Not sure if this happened to you, but sometimes when we are creating a text object, let's say a single line text, for example, we realize that it prompts directly to set a rotation angle of the text without asking for the text height previously. This happens when our current text style has a specific height defined in its properties. So, in this situation, we are on the style floor plan labels, and the text style you can see here, it's defined as 500. So, let's cancel this first. I'm going to access the text style properties, and you can see the height here for floor plan labels is defined as 500. On the other hand, the standard style, let's click on it. Remember that it prompts to specify a text height on screen due to the fact that the value here is set as 0. So memorize this. Now let's go back to floor plan labels, and I'm going to change the height to 0. Apply the changes and close. Finally, on the workspace, after activating the command single line text, the first prompt is to specify the height. Even the default one is 500. I can press Enter to use this one or change to a different one if I want. How to convert multi-line text to single line text and vice versa. Okay, I'm going to insert a multi-line text object. For the text style, I'm going to use standard, and if you look at the label there, you can see it's the current style. Type the alias T, press Enter, and then click anywhere to start defining the window that I want to fit the text in. And now, as this style doesn't have a specific height already defined, I can change it here if I want. So let's set 150 for example. Okay, now let's place 3 lines of text. And as my point is just to explain to you how this works, I'm going to put text 1, text 2 and text 3. Finally, click anywhere to confirm the multi-line text. Now, imagine that later I decided to separate each line, so this is very easy. You just need to explode it, and from now on we have 3 single line text objects here. Now the other way around. In this file I have this floor plan, and in each room I added a label as 2 single line texts with different heights each. One is for the name of the room, and the text below indicates the area in square meters. So it's also possible to merge both on a M text, and there is a command for that. Its name is a bit complex, by the way. txt2mtxt. Yes, it's strange, but actually it's not hard to memorize, as it means text to M text. But don't worry, because once you type the first two letters, it shows up on the command list. Then you press enter, and notice that the texts became a bit closer, and the reason is to follow the spacing that is defined in a multi-line text between each lines. Okay, this is a multi-line text now, and if you double-click on it, you can access the text editor as usual for changing the settings if needed. Another thing, this tool still works even if the objects are displayed randomly around the screen. The only problem is when applying text to M text, they may not organize how we expect. So you have to do it manually. It's simple. Enclose text in object. Now look at the labels that we had on the floor plan, but to simplify the things, I copied them to an empty space here because I think it's easier to understand properly how this tool works. And to be even better, let's move also the areas, which are in a smaller size, a bit below. Now, let's switch to the Express Tools menu, and specifically at the text panel. These are basically some advanced operations regarding texts, and look, there is also this command, the txt2mtxt, that I was focusing earlier in this video. But okay, what we need now is this button Enclose to Object. I'm going to click on it, then I select all the objects, press Enter, and then the first prompt is to insert an offset factor. And be aware that this is not a distance, it's just a factor that still has in consideration the size of the text. As a first attempt, I'm happy with this 1 value, so I press Enter, and for the type of object, let's go for rectangle. Then we have here two options, constant and variable. And to understand better the difference, there is nothing like seeing the result. I click on variable, and now the object size differs according to the length and size of each text. So that's why the rectangle in bedroom 1 is wider than in bath. If I choose constant instead, then there is another box asking me what I want to maintain constant, if the width, the height or both. So this time I'm going to choose both, and now all the rectangles are exactly the same, even the ones around the areas whose text height is smaller. Basically, the system takes the largest rectangle and places it around the remaining objects. Now let's look what happens when we change the offset factor. If I set it to 5, the objects become bigger. The only problem is that it's maybe hard to guess the size that the object will have, unless you have a lot of practice. But you can try a few times until you find the value that you are looking for. Finally, there are two more types of objects that we can use, circles and slots. And the available settings are exactly the same as for the rectangles. One last thing, the text and object keep their independence in a way that in this situation, the circle is not following the text if I change the text size. This was something when I was exploring this command, I didn't understand what variable and constant meant. I thought when we change the text height or the text itself, the object would adapt to the new size, but it didn't. Actually, variable and constant only works for a multiple text selection. Mirror text. In AutoCAD, by default, text objects are not mirrored when we use that command to make a symmetric copy of a specific drawing. As you will see in this situation, the texts are copied but without inverting the letters, just because I think most of the time we don't want that to happen. However, if in a hypothetical situation we need to display the text backwards, we only need to change the system variable mirror text. Press enter, and here we have two options. If I set 0, which is the mode by default, the text is not mirrored. So to enable this ability, I set 1, press enter, and now if I apply the command mirror to these objects at the right, look that now the texts are backwards. Insert a field in a text. This is a very interesting and useful advanced option available in AutoCAD. A field is basically a way to insert data that we expect to change during the cycle of a drawing. This is actually the definition that you can see on the Autodesk website, by the way. As an example, I provided to you this file where I have attached an image from a satellite view of a part of a town right in the center of Africa. Now, suppose the image is already scaled to have its real proportions in meters, the unit I specified for this project. Now I'm going to add a polyline to measure a specific area. Let's make it around these houses, and the accuracy here is not very important. I just want to show you how this works. Then let's add a text object, and I will type for it area of the terrain with the current value displayed here, and the main point is that the area updates automatically if I decide to change the size of that polyline. So I right click with the mouse and go to Insert Field. In this window, from the category list, we can add date and time that could be useful for a layout sheet, among other options. Let's pick up Objects and then press this button to select a specific object, which in this case is this polyline. I click on it, and then at the right section there are several parameters that we can display. Let's choose Area, and at the section at the right, first we can see a preview of the result above, and this means it's going to be 3248 square meters. Then here we can choose the format. At this moment decimal is fine for me. Below it's the precision. And in additional format we have extra options like conversion factor, in case we need to display the result in a different unit than the one I set for the project, and an additional text. For example, I can add an indication of square meters as a suffix. Click on OK and close the window. Now the area is displayed within the text. Also notice that the values are showing highlighted, but don't worry in case you want to print, as on the paper this rectangle around the number will not appear. Finally, as I mentioned before, the great thing of using fields is that I can change the area of the polyline and the value updates automatically. Okay, sometimes we have to save the drawing and open it again to notice the change. But you can always use the command regen to update the value in this precise moment. So it was everything for today. But this time, before leaving, I want to mention that I just started a page on Patreon for CAD in Plan. There you can support this channel to help me keep creating more content here. I would really appreciate that. Even of course, I'm already grateful that you find these videos valuable and that they are helping you to speed up your knowledge. Without your support, nothing of this would be possible. So, thank you very much for watching. See you next time.